Hi, everyone. Welcome to the finals of the Biodesign Sprint. My name is Daniel Grushkin. I'm the Executive Director of Biodesign Challenge. I am very, very lucky to have Dondina Bradley with me here. Dondina is both a BDC Biodesign Challenge board member and also a member of the Mars Wrigley team. Thank you for joining us today. Yesterday, during the semifinals, judges saw projects from teams from 16 countries. They were chosen from over 150 applicants. Each team had 1 month to consider food systems, how they contribute to our health and wellness, and how they, when reconsidered, they can serve both people and the environment. So special thank you to our 34 judges. It's an honor to be among such incredible minds. So thank you. Thank you. Thank you for your time and dedication. And I want to give a big shout out and thanks to the team at Mars. Those of you who have joined as judges, specifically Dondina and Arthi Gopal, Global Senior Director of Global Health and Wellbeing Strategy and Innovation. It's a mouthful. Later today, we'll hear from two fantastic speakers, LinYee Yuan, founder and editor of Mold Magazine, which is an acclaimed magazine dedicated to designing food futures. She'll be followed by Dr. Nicholas Christakis, who's the Sterling Professor of Social and Natural Science at Yale University. He researches wellness and social behavior. So I'm going to pass the mic over to Dondina, who's the Global Vice President of Wellbeing and the Center of Excellence at Mars Wrigley. And Dondina, take it away.
Hello, everyone. Thank you, Dan. I'm really excited to be here. I feel really kind of nervous for everyone. This is awesome. But as Dan said, I'm Dondina Bradley. I have the honor to lead the Health and Wellbeing Center of Expertise at Mars Wrigley. My team is focused on what we call inspiring meaningful impact, which aims to realize our opportunity to impact societal through our business and strategic initiatives. I just want to reinforce Dan's vision. And when you think about his commitment for bio designers of the future, is just wow, to think of the first generation of biodesigners, it's a huge accomplishment and inspires me personally. I'll be brief in my comments, but really want to underscore kind of three pieces, right? Like why BDC, why the BDC participants. We all know there's massive change, right, happening in the world, and we wake up every day to some new news. And I think, though, that understanding of our world in its beauty and thriving capacity is just really, really important. And so this group is really imagining a different future and helping us to think differently about that future. And specifically, I'm a systems thinker, and we're learning from complex systems in this challenge. So imagine the biological system, right? The food system, and even the designer's way of thinking in that system. We're bringing all those pieces and parts together. So thank you for your curiosity, for the conviction that you have, and for connecting kind of the unconnected, which enables us to think about systemic change and not just our change for the world. The next piece is why us, right? Mars is a private family-owned company that's really driven by this belief that the world we want tomorrow starts today. And I couldn't feel more honored to be here with my colleagues. And as leaders, we have this responsibility for where we invest our time and the kinds of decisions that we make. And specifically, my conviction is that the well-being of people and the planet go hand in hand. And so I'm on a kind of a drive, if you will, to really talk differently about how well-being fuels our well-doing. And so the simple choices that I make, that you make every day, how we sleep, eat, breathe, move, connect, right? Bring awareness to kind of problems around the world. It all matters and affects the well-being of people and the planet. So just thanks to Mars, our principals, and just the great opportunity that we have to collaborate with each other and support this challenge. And then finally, I would just say, why now, right? Well-being is that innate capacity to thrive. Innate meaning we have all the answers within us. Capacity, we all affect, right? That capacity itself, whether it's low or high, and certainly thriving. However, we need to manage and be grounded in what's happening in the world. So I think more than ever, we want to put more hope and solutions into the world, really to increase the thriving capacity of people and the planet. So thanks to all the educators, right, the designers, the food scientists, the experts, the visionaries. I just couldn't be more thrilled to be here in your participation for this challenge. So thank you.
Thank you, Dandina. Yeah, it's been an incredible month with you and the Mars team. So thank you very, very much for doing this with us. It's time to now present the student finalist teams. I'm very, very excited to announce basically the 4 teams that have made it to this round. And so, Jeff, if you can help me and show those on a slide, I will announce them. And here they are. So we have Spice Bond, Coast to Coast, Earthlings, 4.66. Congratulations, teams. It's great to have you. Get ready. You're going to be presenting very, very shortly. And now I'm going to present the non-student finalists. Go ahead and please do show this slide. And here we have them. University of Minnesota Biodesign Collaborative, Crazy Cocos, and Chi-Town Bio. Congratulations, all you teams. Get ready. We are going to take a short break as the teams get themselves ready to present. Please stick with us. We'll be back in a few short minutes. Thanks so much. See you soon.
What is this exciting material? Biochar is a carbon-rich, charcoal-like material that is produced by the heating of biomass in the absence of oxygen. This is a process called pyrolysis, which we'll get more into later. Biochar has been used for centuries throughout history by indigenous and farming communities to fertilize soils. What's more is that it's made from bio-waste feedstocks, can be produced at industrial scales, and it stably stores carbon for thousands of years, even in a landfill. How it's made. Bio-waste from agricultural and forestry industries is collected. This might be grass clippings, manure, wheat straw. This material is put into an anaerobic biodigester, where it is heated in the absence of oxygen. This process, called pyrolysis, results in biochar as the output. Now let's compare the carbon cycle versus the biochar cycle. In the carbon cycle, biomass is decomposed or burned, and 99% of carbon is released back into the atmosphere as carbon dioxide. In the biochar cycle, we intervene through the process of pyrolysis, where 50% of carbon from the biomass is stored in biochar stably. We chose to use biochar because if it ends up in a landfill, it still stably stores carbon there. We were specifically interested in it as a black plastic alternative because with infrared sorting, black plastics are currently falling through the cracks of our recycling infrastructure. For this reason, all those black plastics end up in a landfill or as a pollutant. Our material Biome is an incredible substitution for black synthetic plastics because rather than traveling straight from cradle to grave, it repurposes problematic waste and sequesters carbon. Our second component is PHA. PHAs are a class of biodegradable and biocompatible plastics made via a bacterial fermentation process, aka with live microorganisms. Let's take a closer look at what we mean by biodegradable. PHA is certifiably biodegradable by all 6 world standards. This separates PHA from PLA, which degrades only under industrial composting conditions and does not degrade in marine environments. PHA is made through a less energy-intensive process of fermentation that turns waste into a biodegradable thermopolymer that can be manufactured using the existing plastic infrastructure into these Google hardware products. PHA pellets can be molded with heat and pressure. We were able to form our PHA with the CNC machine and aluminum mold. These mechanical properties represent the average properties of PHA. In most cases, PHA is comparable with polypropylene. We used a multimeter and flame test to measure the flammability and conductivity of Biome, and we found that the combined material of biochar and PHA was neither conductive nor flammable. However, there are studies that demonstrate that graphene can be added to PHA to make a conductive plastic. We ultimately chose PHA because it repurposes waste through fermentation, creating living plastic that can easily and affordably be produced at an industrial scale. The microbes that produced our PHA kept company by their bacterial cousins. We decided that our nest mini upper portion would be covered by a bacterial-dyed fabric. By relying on the natural, non-toxic activity of bacteria to produce color, the nest mini can reduce water consumption by up to 500%. While still producing easily reproducible textiles and mesh. To make bacterial dyes, sterilized textiles are inoculated and bacterial growth is encouraged. We chose bacterial dyes because we were inspired to facilitate the production of a product by microorganisms and bacteria. Our solution is Biome, a hardware casing made from stored carbon and microbes. Not only is it a beautiful, natural product that has the potential to offset manufacturing impacts, but it also can be produced using existing plastic production infrastructure. Here we have a sample of PHA pellets that we have injection molded with biochar. Biome has the potential to go a step beyond sustainable material and leverage the power of scale and Google's global impact through carbon sequestration. As industrial designers, we care deeply about the role that mass production can play in meaningfully combating the climate crisis. Our exploration of biochar has been featured in Dezeen, Forbes, and as a runner-up for the James Dyson Award. Our process begins with captured carbon and diverted waste. We suspend biochar in heated PHA and then mold the plastic into Google Nest products. This simple process, we can manage and mitigate two of our most problematic waste streams, organic waste and petroleum-based plastics. Looking toward the future of Google hardware, fully compostable or partially compostable Biome products could be disposed of in any backyard. We've added natural substrates from ag waste to create a visual signal and indicate to consumers that the plastic they're holding is biological. These visual reminders create lovely colorways partnered with fabric dyed from different bacterial strains, ranging from ocean hues to earth tones. On to prototyping and user testing. Sadly, we cannot pass samples around to each of you in this virtual format, but instead we've asked a few of our classmates to describe the material differences between the Google Nest Mini and the Biome material replacement. We asked each participant to hold both hardware casings and describe the differences between them. Enjoy! We've created a material for Google products made by microbes for microbes. Biome is a resistant, carbon-storing thermoplastic. Due to the diversity of bacteria and source substrate, we're presenting 3 possible colorways for different user identities, all designed to fit naturally into a home environment. Part of our visual language will include a new Google graphic that uses colors representative of nature, growth, and decay. Looking at the product lifespan from cradle to cradle, Biome is a circular solution for hardware casing that seeks to mitigate the climate crisis through carbon capture and turning waste to treasure. Thank you for your time and consideration. Bye!
We're an interdisciplinary team that in creating our material, we fell in love with the idea of community-driven databases. Our story starts in a possible future where Google can tell us of its physical histories. In this presentation, we're showing you the journey of the creation of a materials database using an example of environmental remediation. To build this materials database, we have found the following datasets, as well as considered the intensiveness of processing methods to help create a weighted index in order to create resource profiles. When considering a certain system as a potential lead, we have highlighted 3 requirements in developing a case study. 1. Are the genetic resources that we use local? If so, is there any way in which we can engage in benefit sharing? How do we responsibly use this genetic resource? 2. Can we empower the local community to help us solve our sustainability questions? And 3. What is our local footprint? Do we want to leave a mark? One sample in our database is a waste stream from leather tanneries. In the process of making leather, raw hides are treated with chromium. The chromium is being converted into a toxic compound in this process, and the tanneries need to find methods of disposing it safely or transferring it to treatment plants. We are talking about thousands of liters of water for a single tannery. Is there potentially a local genetic resource that can bioremediate the wastewater? In India, it's home to many tanneries, and microbes in chromite mines in India have been found and characterized to convert hexavalent chromium to trivalent chromium using a special enzyme that. From our data streams, we have found waste stream data, consumer material databases, and a profiling of organisms with properties. By taking advantage of the neutralization of the tanning liquor, we see a possibility in developing a low-intensive bio-based solution which involves the optimization of our organism of interest as part of a fermentation process. Through some rough modeling of the purification process, we have estimated that at best, we can acquire 60 grams of trivalent chromium for every 120 grams of the chrome pickling powder added to every 1.5 kilograms of pelt. With such a great yield, trivalent chromium can be used for shielding in electronics as well as plating. Opportunities can be made to create an eco-chrome finish. The legacy of leather tanneries is currently crushing the industry as wastewater is incredibly difficult to process, and it is impacting other economic resources such as agriculture. In our journey of working with hexavalent chromium, we had found untapped potential within readily available datasets of waste streams around the world.
Hi, everyone. I'm Alex Kizalewski. I'm Biodesign Challenge's Partnerships Director. I'm super excited to kick off the day with our 4 finalist student teams. And so we are going to start off with the first team, which is Spice Bond. We're going to show their video right now.
Imagine a world where spices were a uniting experience, an opportunity where people could come together to bond over a meal and learn about cultures from all over the world. Our project, Spice Bond, sets out to unite food, culture, and community in a zero-waste, eco-friendly way. There is so much waste in the spice industry. Oxford University states that 80 to 90% of spices are left over as spent residue. While the number of farmers that grow herbs and spices are vast, the number of companies that trade and market them is not. Looking at packaging for spices, whether single-use packets or small jars, contribute to the ever-growing global waste stream, which is expected to grow by 70% by 2050. As the spice industry continues to flourish with a compound annual growth of 6.7%, how can we lessen the impacts of the spice market while creating a unique and connecting experience for the consumer? Buying spices in excess can lead to a waste of resources. Recently, there has been a big shift from glass bottle packaging to plastic due to its durability. A bottle of spices can sit in your pantry for years untouched, getting hard from humidity and becoming unusable, ultimately leading it to being thrown in the trash. Due to these 2 factors, more plastic is added to the waste stream. According to Oxford University, bottled spices sit in warehouses for up to 2 years before they even enter your home. As for the spices themselves, the majority of spices purchased today are not sustainably produced. The Dutch Sustainable Trade Initiative lists loss of biodiversity as a key issue associated with spice production. From a user experience perspective, consumers note that the spice aisle in the grocery store changed much since the 1970s. The majority of spices found in grocery stores today are individually packaged in plastic containers or vacuum sealed with cellophane. This encourages a waste culture of constantly replacing containers. In our research, we found a 2019 study by Wonpul and Sabra stating that food is the most unifying cultural factor, with 84% of Americans saying food genuinely has the power to connect people of different cultures and backgrounds. The spice blends at Spice Bond are authentic from specific regions. Each blend includes information about the region and culture that it is derived from. The blends can be applied to a variety of potential dishes, but each spice blend comes with a recipe for a recommended dish that the consumer can enjoy. The physical health benefits of spices are well documented, with specific spices alleviating a variety of ailments. Our spice blends will utilize a variety of spices, many of which have healing properties. While ordering spices, our consumer will be able to input health conditions, and the website will suggest spice blends that will aid in lessening their symptoms. While researching, we found a 2022 study from Edith Cowan University showing a link between mental and physical health improvement from learning to cook meals at home. A big motivator behind creating Spice Bond is making cooking accessible and enjoyable for a wide variety of people. At the end of a long day, our consumer can melt their day away as they watch their spice blend dissolve and blossom into a new favorite dish. Introducing Spice Bond, an organic and responsibly sourced spice blend tile that minimizes packaging waste while creating a culturally connective and healthful experience for our consumer. Offered on a subscription basis, the user can decide what spices and how much they are going to eat over the course of the month. These spices will be presented in a break-apart tile to eliminate single-use packaging. These tiles will have patterns inspired by the architecture found in the location the spice blend originated from embossed on the front, and then an easy measuring system embossed on the back to break off the exact amount needed. Our material is created using spices, cornstarch, water, and soluble pectin. With the dry ingredients prepared, we then boil the water, pectin, and a pinch of sugar for 1 minute. The mixture is cooled slightly, then added into the dry ingredients and stirred. The mixture can then be pressed into the desired mold and placed in a dehydrator for 3 hours at 115 degrees. This results in a dried, firm spice tile that is then demolded. The cornstarch in our material is effective as it is a carbohydrate made of many bonded molecules of glucose. When warm water is added, some of the bonds between the glucose break and the starch undergoes gelatinization. The soluble pectin is a natural occurring polysaccharide that aids in the solidification of our material and has no taste. It requires heating and a small amount of sugar to be activated. It also acts as a preservative. We dehydrate the material to remove moisture, which would be problematic for preservation. Spice Bond will come in a biodegradable inner and outer packaging made out of spice spent and improperly dried spices, as this is the greatest cause of spice loss. Many spices, such as clove, oregano, thyme, cinnamon, and cumin, have antibacterial and antifungal properties that will benefit the packaging. Turmeric spent will be added to the box to act as an insect repellent, while mustard meal will be added as a weed suppressant and fertilizer, which means the box can be used as a plant starter or composted after use. Each month, Spice Bond will have a limited edition City Spice Blend in collaboration with rotating urban gardens around the selected city. In this collaboration, the urban gardens could sell their own spice tiles to further support outreach to their community. World culture is important, but we also want to feature the rich cultures that exist within the cities around us. Our first City Spice Blend will be rooted in the city of Detroit, where Spice Bond originated. For our Detroit blend, there are 3 unique embossed patterns representing 3 areas including the North End, Midtown, and the East Side. These patterns take inspiration from historical architecture features on homes adjacent to low community gardens. Spice Bond sets out to make a unifying cooking experience, bringing together food, people, and culture in an equitable and straightforward way. Through biodesign, we will create an organic and simply sourced spice tile that will nurture our ecosystems and our connected healths.
Hi, everyone. Welcome, Team Spice Bond. Hi, Shay. Hi, Sophia. Hi, Sarah. We're going to move into Q&A. Judges, if you have a question, please, now is the time to turn on your video and your audio and ask away. Avni, please start us off.
Hey, wonderful work, Spice Bond team. Love the concept and idea. My question to you is around, the global range of the spices that you're using in your proposal, which I love that you're using spices that would be relevant to a certain region and making the custom blend. Have you thought about how you would mitigate the footprint with a global supply chain and shipping spices across the world to create these custom blends?
I I think a lot of it, well, one, we want to focus on fair trade spices, which doesn't really help the transportation part of that. But we would also be working with like urban and local farmers that would contribute to that. So that transportation would be lessened in that way. But yeah, overall, I think it would probably be more like the local part that would have a larger impact.
Thank you.
Thank you. Francesca, please go on.
Hi, everybody. I really loved your project. Well done. I wanted to ask about the community gardens aspect of the project. I want to ask if you guys can maybe tell us a bit more about it, about the story, the meaning, the values that you see in this aspect, which to me is one of the most interesting. And then maybe if you can add something on what would be the exact amount needed for the recipes. You're indicating that at the back of each cube there are some levels or grams. I don't know what you're imagining to put there to be visual, but in the video you say for the consumer to use the exact amount needed, but how would we know what is the exact amount needed? Thank you.
Yeah, I'll take that. Thank you for your question. So we actually talked to a few urban gardens around Detroit and kind of figured out what their process was, and we decided that the limited edition City Spice Blend, we would be partnering with them to figure out the amount that they would give to us. So then we know how many we're able to sell. And then we would give the proceeds back to them to help further their community garden. And then as for the exact amount needed, so on the back of the spice tile, there are indicators of how much a tablespoon is. So each tile is a tablespoon, and then within that, there are markers for half a tablespoon and a quarter tablespoon, because we looked at different recipes and seeing the amount of spice blends needed, and it's almost always in tablespoon increments. And so for that, when you're on the website, you would put in how many people you're looking to feed, and that recipe, we would ship out the amount that you would need for 4 people for that recipe to you.
Thanks, team. Sarah, please.
Hi, Team SponseCon. That was an amazing project. I have a question regarding your user experience research. I'm specifically curious about what made you choose a spice blend versus individually packaged spices. I'm wondering if you looked into the purchasing behavior from the consumer side and see what motivates them to purchase spices individually and then mix and match different blends on their own for different dishes versus purchasing already made spice blends. And also, what is the impact? So like when you're looking at the market in general, what percentage of the spice market is individually packed? What is the demand for that versus the spice blends?
Thank you for your question. I can take that again. So we chose spice blends to make it accessible for people who maybe haven't cooked before and are looking to kind of get into that, because having to go out and buying 10 spices in order to create a spice blend is, one, a huge price point, and also kind of overwhelming someone who's never tackled that before. And then for like making it appealing to the user, we really focused on the experience aspect of the tile. So the tile is layered with the spices, so different colors when it's dissolving in the pan will like blossom and come through to create like a new unique experience for the user.
Thanks for clarifying. Thank you.
All right, judges, any other questions for Team Spice Bond? Oh, Francesca.
I actually do have another one if I'm allowed.
Please, yeah, we have just a few more minutes, please.
Perfect. So, guys, maybe from someone we haven't heard of from yet, what would be the first thing you would do if you were to win today? Of course, by celebrating with regards to the development of the project.
I can take that one. So the first thing we'd probably do, we'd probably reach back out to our community garden partners and kind of figure out, well, right now it's fall, but I think maybe once it became more summer, spring, we could really start to develop and figure out their sourcing, like how much we would be able to provide. I think we'd also like to look into finding different partnerships and things like that in the meantime.
Thank you.
Justice.
I appreciate your articulation of how local production could sort of address the carbon footprint aspect of manufacturing and disrupting sort of emissions. And I wonder if you could articulate a little more or a bit about the potential applications in other industries besides spices. I'm thinking about this because your proposal seems to be all encompassing, from packaging to local production to users. Have you thought about other industries that this sort of omnibus approach might benefit?
I mean, in relation to the project, we've really focused on spices, just given the time. But the approach could be taken to really any food-related thing, like the urban gardens produce vegetables and fruits. So that's a clear one. I think there's potential for it to be taken into multiple, like different sectors. You could have be like fashion in your like garments, sourcing things like your fibers and everything from more local sources than transporting it all over the globe. I think that's just one way that it could be taken past just spices. But thank you.
Thanks, Justice. We are at time now. Thank you so much, team. Love this project so much. All right, we are going to move on to our next team. You guys can turn off your videos, and we're going to play the video for Team Coast to Coast.
There are many factors impacting climate change and degradation of our natural ecosystems. When looking at the candy industry, we can identify two major problems: the use of sugar and pollutant plastics. Sugarcane is largely an unsustainable crop. Sugar farming contributes to the degradation of the Amazon rainforest through extensive land use. Plastics that are found in candy packaging contribute to pollution. Plastics that often break down into smaller plastics called microplastics. These microplastics are found in our soil, our waters, and even in our digestive systems. Humans consume a large number of microplastics. But what if there was a sweet solution? Introducing candy caps, a new mushroom-based confectionery that provides a sustainable alternative to the sugar industry and combats microplastic pollution. Candy caps incorporates the hybridized version of the candy cap mushroom that, in addition to providing a brown sugar aroma and flavor, secretes enzymes that break down plastics in the human digestive system after consumption of the candy. Candy cap mushrooms are known for their sweet maple syrup-like flavor. They are one of the few sweet mushrooms in nature and have been incorporated into many baked goods. We will be bioengineering a candy cap that has the ability to break down microplastics based on the numerous other mushrooms that have been found to secrete enzymes that also break down plastics. We will be using gene editing technology to engineer a candy cap mushroom that has the ability to break down plastics. This is accomplished by using a plasmid designed to express the PETase gene, an enzyme demonstrated to break down plastics into chemicals that are safe for human consumption. Once consumers eat this mushroom candy, the PETase enzyme will break down plastics in the consumer's digestive system into waste products that consumer can then pass. This will effectively reduce microplastics both in the bodies of people, but also in our waterways, since less microplastics will be passed from humans into waste systems.
Hey guys, I'm Jamie. I'm the founder and CEO of Hedgehog. We build robotic fungi farms. Just some of the opportunities with mushrooms: they transform waste ingredients into foods. We feed them agriculture residues and forestry residues. We can use them as small biofactories to produce protein or sugar replacements or health supplements, and that's fantastic.
The candy cap mushroom hybrids will center sustainability from start to finish. They will be grown in sustainable farms that use agricultural waste products and plastics as food sources for the mushrooms. Mushroom farming has been proven to be a more sustainable agricultural solution to traditional farming practices. Mushrooms' ability to grow in large quantities while taking very little space, unlike sugarcane. Once the mushrooms have passed the growth stage, the mushrooms will be dried and ground into a powder. Some of this powder will be mixed directly with the ingredients for our candy. The rest of the powder will be encapsulated in a casing in the form of small granular beads that will degrade in stomach acid. These beads will be gently folded into vegan chocolate, and the loose candy cap powder will be mixed in as a flavoring agent. We also wanted to focus on the colors when we designed our candy. Consumers are drawn to bright colors in their foods, and we wanted to offer a variety of color choices. In designing our packaging, we also wanted to emphasize both consumer desires and sustainability. Our packaging is made from mycelium, a sustainable biodegradable alternative plastic, and it incorporates bright colors to visually catch the consumer's eye. When the consumer buys candy caps, they are opting for a product that is tasty enough to replace other candy products and will serve both their bodies and the ecosystem. This product will be marketed to all chocolate candy consumers and to shoppers that are focused on health and wellness. To market this product, we will feature the health benefits this candy has, the sustainability that is focused on from start to finish, and its unique flavor agents that are competitive with candy that already exists on the market. We want to emphasize that this candy is new and exciting, but grounded in traditional candy textures and flavors that allow it to seamlessly transition from their favorite candy to candy caps. We do foresee some challenges in the use of PETAs in the candy. For instance, it was important for us to ensure that PETAs is not broken down during the initial stages of consumption. This is why we encapsulate some of the candy cap mushroom in casing that needs stomach acid to be broken down. We anticipate some challenges in not degrading the PETAs when dehydrating and drying the candy cap mushrooms. We also do not know how long the PETAs would have to be in the gut before it starts breaking down microplastics. Despite this, we are confident that these mushrooms will have the ability to express enzymes such as PETAs that degrade microplastics and can be grown on semi-plastic diets. Our next step for this product is to create our PETAs fungi plasmid. Insert this into a candy cap mushroom and then grow these candy caps on a diet of plastic to see if they secrete enough PETAs to break down that plastic. We are hopeful for the future of candy cap mushrooms and confident that our product will positively benefit both the health of the individual consumer and the planet. Saving the planet never looked so sweet.
All right. Thank you, Team Coast to Coast. We are back. Let's hear from the judges with some questions. Nick, why don't you start us off?
Hi, I was interested to understand if there are any other consumer benefits that you might talk about beyond the microplastic. Health benefits.
So we have seen benefits in many other kinds of mushrooms. While we don't know specific to the candy cap, there are benefits and psychological benefits to using mushrooms, as we see in different kind of coffee additives, to other products as well. So I think there could be other benefits in that way as well. Also,
I was chiming in saying that candy cap mushrooms themselves have been proven to have anti-oxidative properties and things that are more beneficial for your immune system and gut health. There's some research that Shar was able to pull for us, and though she's driving right now, she was found a lot of articles that showed how mushrooms themselves are just overall beneficial and have a symbiotic relationship in the gut.
Yeah, and I can add to it. I just had a stop. So, yes, definitely. So we did some research on the candy caps, and we were finding out about the health benefits. And we found out that it definitely has benefits related to your brain health, and then it has definitely less sugar, and it is they are known to kind of help with the immune system as well. So other than just being a substitute of sugar, there are other benefits that are associated to it.
And could I ask a follow-up question? What made you choose microplastics over the other benefits that you could have chosen to talk about for the candy cap mushrooms?
Yeah, I think we chose microplastics because we really have an opportunity to not just help the individual person, but also really make an impact on the environment. Because when we're breaking down these microplastics in the gut, sure, we're removing them from this person, but those are the same microplastics that usually over time would also maybe get passed through the person and end up in our waterways and our oceans. So really, I think one of the prompts was, how do we create a food that connects community and human beings? And I think by really solving those two problems with one candy, really has an impact.
Thanks, Nick. I'm going to go over to Winslow.
Oh, sorry.
So yeah, it's a really fascinating and impressive presentation. Seems like you guys are tackling maybe 5 different 5 different challenges. And I was just wondering if you could, because it seems like the sort of most obvious one is the ability for people to be able to digest or to deal with their own microplastics. But there's also issues with health. There's issues with the sugarcane trade, issues with packaging. I was wondering if you might be able to sort of, for your team, sort of list which one is sort of most important in order of most important to, obviously they're still important, but just because from a sales perspective, it seems like there's a lot, and just sort of from a focusing of the message, I'm just curious as to how you would rank those.
Right. So when we were looking and analyzing both the candy industry and the plastics industry and the pollution that causes, one thing we found out from prior feedback and customer discovery was that most people care about taste. Most people care about how it feels to them. So one of the biggest things is, how you can make a candy that is healthy and tastes good, and also resemble a mushroom. I think that having that kind of biodesign and biomimicry with the microencapsulation, copying sporulation from mushrooms was pretty ingenious in that design, and also just the way that it can have this bright poppy color that is available for consumers. At the same time, the value proposition from our end is, again, like we focused on, was just the way that mushrooms have been proven to be edible while growing on plastic waste, and how they have enzymes that we can utilize to help with microplastics in the body. It doesn't have to be the biggest seller, but it can be the biggest way that it can be differentiated on the industry market.
And I would add here that, initially when we were brainstorming, we definitely thought about, this real problem of sugar around the world, and how it's affecting people and their health. And so, we looked into the sugar reduction first, and then we kept developing our project, and we thought of other issues as well that are associated with health. And so, like Brian just explained, we came to the microplastics and finding solutions in our candy as well for that.
We have more questions, so I'm going to keep going forward. Cocos, and then Corinne, if you have a question, please turn on your video. But Cocos, please go on.
Thank you. 2 questions. One is, I might not have understood properly from the presentation. So is the candy cap mushroom the kind of the main ingredient in the product that you're proposing, or would that be an additive? And what impact does it have on the texture and the taste of the candy product itself? And the second question is relates to the capability to dissolve microplastics. So that's kind of a very strong capability inside a person's digestive system. Does it dissolve anything else than microplastics? Or in other words, can it pose a danger to the digestive system?
Yeah, I can. So for the first part, the clarification there, it's an additive, but it's grounded up and then added to the candy. But one of the reasons that we chose these candy cap mushroom was their flavor. So they have an aroma and a flavor almost similar to maple syrup. People eat them, people add them to dish already. So they do add and enhance the candy. And then to talk about maybe off-target effects in the digestive system, that's definitely possible. That's something we just have to find out during testing and further engineering.
Thank you. Corinne, and then Francesca, you'll be our last question.
Wonderful, thank you. I really appreciate you focusing on mentioning ag plastic. So I'm just curious to know more about how you're imagining working with ag plastics, and if specifically you have any specific ideas. I think this is really exciting. Just having known the agriculture in Salinas, where like 30% of our strawberries nationally come from one little valley, and they use so much plastic. And then just down the street is Monterey mushrooms. So what are you thinking of in terms of these systems of the agricultural waste that you're going to work to grow the mushrooms on? I'm just really curious because I find this really exciting.
Right. So when looking at the food systems, a lot of things we realized was that there isn't like a one size fits all solution. So when we think about regenerative mushroom farming, we're thinking about going into like small, individualized and specified areas where you can grow mushrooms and candy caps on these locally sourced waste streams and be able to utilize these small bulbs that overall make a big impact. That was the intent. Anyone wants to add on to that?
All right. Francesca, for it.
Thank you. Very quickly. I love it. Well done, guys. Really love it. And then, mushrooms, right? I mean, great. They're going to be the future, probably with algae. They're our future. So well done. And then I've never heard of anybody thinking about cleaning our guts from microplastic. I just found it genius. Even if we don't know, and you guys said very clearly also, that's why I appreciated that you put in the end of the video the challenges that you face, even if we don't know yet whether this might be actually successful in cleaning from plastic our intestines. That's the premises for you to do research there. And I love that you have the passion for this trajectory. My question is, I would be curious to know why the candy market, because you could take mushrooms, and with that intention that you have, you could do any type of products. Like I have these things, for example, just mushrooms that you take every day. We can talk about the environmental sustainability of packaging here, but I was just curious to know why the candy market? Thank you.
I can take on that. So initially, when we look into candy cap mushrooms, there's a specific geographical character to it. So we chose candy because candy production relates deeply with this DIY culture. So handicraft culture, which it's deeply associated with community culture as well. So we imagine that proposing such an idea can be applicable and can be adoptable to different parts of the world. So depending on their climate, their geographical features, and their mushroom species, they can fuse different ingredients together to create their own flavor of the culture locally. So we thought there is a versatility feature to this idea.
Thanks, Francesca. Thank you, team Coast to Coast. We are going to move on to our next video, next team. Thank you all. You guys can turn off your videos. And our next video project is going to be Earthlings. When you're ready, Jeff.
Earthlings, ocean brewed gummies bringing human and microbial cultures together. It's the 3rd of June, 2032, Kolkata, India. It's very hot. The temperature is 45 degrees and people don't farm anymore. Actually, crop farming has started to collapse all around the globe. A decade ago, food production was one of the top causes of greenhouse gas emissions, contamination, soil erosion, deforestation, and biodiversity loss. At that time, 2 billion people were overweight and 800 million people were undernourished. Many suffered from cancer, heart disease, and diabetes. That's why people and companies realized that they had to change the way we eat and produce our foods by designing regenerative food systems to harmonize both environmental and human well-being. Community and culture have become centric to our production systems, and the coexistence of global and local scales have become the norm. When Anushri, a 36-year-old Bengali lady, goes to her local grocery store, she now buys microbial fermented foods called Earthlings. Earthlings might look just like another delicious snack, but they actually encapsulate innovation, science, and food design. These gummies are probiotic snacks that provide little moments of joy and recreation for all members of the community, while belonging to a regenerative production and supply system that is healthier for the planet. Earthlings is a candy that can be produced anywhere because the main ingredient is microalgae, a microorganism found in the ocean. The strain used is spirulina, a popular type of blue-green microalgae, also known as cyanobacteria, that provides these violet, blue, and green shades typical to Earthlings gummies. Earthlings are an alternative source of protein, for which the spirulina algae has been given an accessible taste for many people around the world. To make it possible, food designers, biologists, and food scientists have used unique and cutting-edge techniques to enhance the nutritional benefits of spirulina. Algae is a natural carbon sequester and a source of oxygen. Through photosynthesis, it absorbs CO2, nitrates, and phosphates. In return, it provides the atmosphere with clean oxygen and serves as a food source and shelter for marine animals. The list of its benefits for the environment and human health is lengthy. The water footprint of spirulina is almost 20 times lower than that of wheat, and its land use footprint is 450 times lower, and its carbon footprint is 0. It is high in proteins, vitamins, and minerals, as well as fatty acids such as omega-3 and omega-6. It is high in bioactive compounds such as phenols, phycocyanin pigments, and polysaccharides, making it a natural antioxidant and anti-inflammatory. Earthlings are produced at large localized confectionery Mars Wrigley factories, where machinery and clean energy supply are already present. The gummies are made of spirulina liquid, which has been fermented by lactobacillus bacteria. The second stage of fermentation is crucial to remove the fishy smell and taste of spirulina, and also to enhance its probiotic power and nutritional value by boosting the protein and vitamin content. Finally, for a naturally sweet product, the jellies are infused with local and seasonal fruit to add flavor, color, nutrients, and a cultural twist. This would help Earthlings to be a product with flavors that are recognized in the community where it is being introduced, as well as open up conversations about restoring indigenous fruit. The process of mixing the fruit is facilitated by the creamy odor and taste of the spirulina extract that can adapt to almost any flavor profile. The manufacturing setup includes a 2-bioreactor system. Spirulina is firstly grown and processed and then moved to the fermentation chamber through a pressure system, where a host of lactobacillus is injected for the second fermentation. After 24 hours, cubed fruits are infused into the product, which gets stirred in the bioreactor to ensure they are distributed evenly to the liquid. At this point, agar-agar is introduced into the bioreactor at room temperature, and the liquid is allowed to move into the molds. These are left to set for an hour and then packaged in compostable bioplastic membranes based on algae, making the end product circular and waste-free. The end product remains shelf-stable for 2 to 3 months, and if refrigerated, it lasts up to 5 months. In the process of adopting innovative foods, no one wants their culture to be lost. Food is what brings people and communities together. Even though harsh times, people keep eating and keep food traditions alive. Microbial fermentation has always been part of our culture around the world. Dairy, bread, wine, and ferments have been at the base of different diets. Over the past years, human cultures have evolved and adapted to technological changes in order to combine the culturally valuable to the environmentally necessary. Food is a powerful tool to communicate complex issues in an accessible way. Transparency about the production process is key to educate customers about the nature of what they eat. For many years, people were unaware of their food sources and disconnected from what they eat, which often ends up harming the environment. Local open labs have therefore been set in different locations to promote the product while teaching kids about the world of microorganisms. In these pub labs, children can see their gummies being grown in the bioreactor and recognize how lactobacillus bacteria can change the nature of spirulina. Earthlings, bringing human and microbial cultures together.
All right, welcome Team Earthlings for your project Earthly. It's good to see all your faces. I love the backgrounds. Judges, when you have a question, please join us and turn on your video. Or Ken, start us off. Or Ken, you're muted.
Very wonderful presentation. Congrats. I was just curious. I mean, there's a lot of spirulina-based desserts out there, from dark chocolate, spirulina that has dark chocolate, other kinds of food supplements. I was wondering, if I am in the supermarket looking at the aisles, how does your product compare with what is exactly out there today? How much user research you did, how much tasting you did it on your own? I'm just curious.
Hi, thanks for your question. And well, one of the things that differentiates our product is that it has probiotics. We are fermenting it with lactobacillus, and so it will have the added health benefits of having probiotics in our diet. And in fact, we tried to create these candies by ourselves, and I'd let my teammates talk about how we tried to create those and have them, and what that.
Thank you. Sarah, next question.
Hey everyone, this is a great project. I really do appreciate that you address so many different aspects that are involved in this and making this product. I have a question about the manufacturing process, specifically the fermentation part. So you mentioned that you'll be producing this locally using and retrofitting infrastructure that already exists. So I'm wondering, have you looked into the limitations of that when it comes to local production? Because that manufacturing capability is not, as of now, currently a global infrastructure that is available locally in all areas. So if you have any points that you would like to clarify, I would appreciate that.
Yeah, of course. Yeah. So there's a few answers to this question, actually. So we looked at the different places in the world where we can actually grow spirulina in terms of the spirulina needs, right? So it needs to grow in a high temperature. So if I'm correct, it's around 30 degrees Celsius, which of course is not possible in the whole year round in Northern Europe, for example. So then we were looking at growing it naturally or outdoors versus in bioreactors. So in the case of outdoors, we looked at spirulina and how it is very resistant to parasites, and that it is usually actually grown in ponds. So it wouldn't actually be a problem to grow it outdoors where the temperature would be high enough, for example. So as some of our teammates are from India, we actually looked at the climate there and looked at in places such as India, it would actually be possible to grow it outdoors. Whereas if we are looking at the northern hemispheres, such as Europe, we've found one company, for example, is called Algren in the Netherlands, and they have done and are doing a lot of research on spirulina and growing it in these tubular bioreactors. And then, of course, comes the question of energy supply. So energy would then have to be produced via green energy, so maybe solar panels or others. And this company in particular, we looked at their research, and they're also looking into mixotrophy. So basically, they are able to use different kinds of spirulina, and ones are producing CO2 and other ones are actually eating CO2. So they're able to create this, circular cycle of how to feed these bacteria. So these are just the different things that we looked into on how to make it as circular as possible. And yeah, I guess that answers your question. So we looked at different climates, basically, in terms of the cultivation.
I just want to clarify one point. Thank you for the answer. But you discussed that this is a two-part process, right? So you basically need part one, that you produce spirulina, you grow spirulina. And as you said, that can be done outside of a bioreactor in ponds. That can be done locally, and it doesn't have to be sterilized. How about the second part of the process? And also, are you planning on doing part one in a different area and then ship that to the second location for part two? Or is that going to be our part one and two happening all in one location?
So I can pitch in here. It's like, again, this system is kind of, we can do it, we can grow the spirulina elsewhere and then do the fermentation in one place. We could do the fermentation and spirulina in a place that is equipped, like a company or a factory, like a Mars Wrigley factory, and then create a shelf-stable product, which we are then getting the product to the people who need it. And then we can also grow them together in any kind of area, because bioreactors are sterile environments by themselves. So the fermentation and the production of the spirulina is going to be quite, it's not going to get contaminated automated in that sense. The main problem would be to obviously get the bioreactors to the vulnerable places, which is something we did deliberate on, and then finally came to the conclusion that the solution to this problem would be to create a shelf-stable product so people can get it until we are able to get this equipment everywhere. And for the like local production, we were thinking about obviously indigenous fruits. We would be getting to like Mars Wrigley factories are all over the world, so they'd get the indigenous fruit of those countries. Like for India, they would get jamun, which is like an indigenous fruit here, which has like good diabetes, like it prevents diabetes and things like that, while it's still sweet. So stuff like that.
Got it. Thank you.
We have just a few more minutes. I'm going to go Paula, and then Avni, and then Alice.
Great, thank you. Great project, folks, and thanks for the presentation. I guess my question for you is, you talked about this ability to use the spirulina in addition to localized fruits and to kind of speak to the local repertoire. Obviously, some of these fruits are used by the local communities already. So have you thought about, because I'm assuming this would be a success, right? And it would create wide demand in many places in the market. And so have you thought about sort of the balance between making sure that, you know, these communities would have continuous access to fruits that they're used to? How are you looking on this equation in terms of the demand, but also the supply that you need to have, and ensuring that the access that these communities have doesn't get jeopardized?
Again, so that's a great point. Thank you for asking that question. Here in India, we kind of grow certain fruits all around these are basically our berries and things that are grown alongside crops. So they're like fruits that we are sold on the roadside in some sense. And so we were thinking about how do we get in touch with those farmers and get them to get as much profit on that fruit. So they are moving away from monoculture and starting to grow these fruits as continuous parts of their production, instead of like just side products that they're able to sell for like small amounts of profit. And so I think that once we create a demand for these fruits, and because the local parents and local children are used to having them in their diets, they would then be happy to eat them in these like gummy forms. We are able to then empower the farmers even more to grow these fruits in a better manner as well. These fruits will have the added benefits of, remediating the soil, because those plants are quite good for the soil. In fact, some of the plants that we looked at, they have their roots have certain properties that are reintroducing nitrogen fixation bacteria into soil. So these are all like positive effects of some fruits, certain local fruits that have kind of been suppressed in the name of like more common fruits like apples and stuff like that. We kind of have started growing more in India.
Great, thank you.
Thanks, team. We are at time, so Avni and Alice, if you can make super, super quick questions. Otherwise, I'm going to have to move on to the next team.
I can make a super quick question if they are able to answer. Did you guys talk to any consumers about how they would receive this product? Because not everyone is used to consuming algae and there could be a barrier. So have you talked to anyone about that?
Yeah, so I can just quickly respond to that. So we talked to some parents actually, because we were looking at making these snacks for children. And of course, we needed to consult adults for that. And so we looked at, we asked the questions of, okay, how should we present this if we want kids to eat it? And we got the responses, well, it needs to look good, basically, look fun. So the packaging and the candy itself. And then it has to taste good. And so we were really focusing on, in the pictures, you could see the snacks that we made were really like fun, colorful, and they would be sweet because of the natural fruit ingredients. And then the packaging, we thought about the packaging as well. We wouldn't be producing it ourselves, but we would want it to also come from the algae resources, so that it would come into this circular product, and then design it basically in a way that is marketable for children, I guess you would.
Thank you.
We really need to move on. I'm so sorry.
No worries. That's all right.
Thank you. All right, job team. Thank you again. Awesome project. We're going to move on to our final student team for the day, which is 4.66920016.
The design structure of sugarware ties deep with the shape of sugarcane, which is the plant that accounts for 79% of sugar produced globally, and 40 to 60% of the total sugar production domestically. It is a suitable taste-enhancing spoon for artificial sweetener substitute, with great features made from the bagasse, residual waste from sugar production. Inspired by the sugarcane's growing mechanisms, with its leaf spindle enclosed within the sheath of the older leaf, creating a spiral-like shape along with its growth. The feature of stackability of the spoon enhances further with this structure and creating possibilities for multiple usage. There are several bumps covered in the bottom of the spoon, where they will eventually be touched by the taste buds. This feature is originated by Studio Jin Hongju's work called sensory stimuli, but we wish to aim for further taste enhancement by adding ligand coating into these pumps to create in-depth contact surface for simulating sweet taste. We figure that if we can permanently bind sweetness-triggering ligands to tableware, we'll be able to simulate sweetness receptors T1R2 and T1R3 without the actual injection of sugar or artificial sweeteners. Monosaccharides, disaccharides, amino acids, sweet protein, and synthetic sweeteners all found to be ligands that trigger sweet sensing receptors.
Specific potential ligands would be glucose, sucrose, saccharin, aspartame, coricic acid, monolin, somatin, and neohesperidin dihydrochalcone. Research is inconclusive of whether oligosaccharides are capable of activating sweet receptors. Research shows that natural caloric sugars and artificial sweeteners may utilize distinct pathways. Caloric sugars depend on the influx of calcium ions in the CAMP and pKa pathway, while non-caloric artificial sweeteners induce IP3-mediated calcium ion release. However, saccharin, an artificial sweetener, appears to activate both, thus there may not be a clear separation in the case of all ligands. Natural sugars activate brain reward areas such as the dopaminergic midbrain area in the striatum, while non-caloric sweeteners do not.
As a healthier sugar alternative, our product would potentially reduce environmental impacts by reducing cane sugar production. Sugarcane are grown in monoculture setting in tropical area. This can cause biodiversity loss and soil degradation, leading to a series of problems including increased soil acidity, decreased soil fertility, and destructions of beneficial microorganisms. Replacing cane sugar with our product would also reduce the water footprint in sugar production, which takes around 210 liters of water per kilogram of cane sugar produced. There are research yet to be done to make sugarware possible. For example, we still need technological breakthrough on developing a permanent ligand layer that attaches to the spoon. Researchers should target the excitement of two sweet sensing pathway that was introduced earlier. First one being the CAMP/pKa pathway, second one being the PLC beta-2/IP3 pathway. After these technologies are made possible, next steps would be the application of ligand layer on sugarware, ensuring efficiency and longevity of the products.
All right. Welcome, team. Judges, when you are ready, please turn on your cameras and we will move into Q&A. Alice, Paula, please start us off.
Sorry, I think Alice had a question. She wanted to ask one last time, so I'll follow her. I'll follow her afterwards. I do have a question, but I'll follow her. Alice, please, you first.
Okay, no worries. Yeah, I was just curious from an experience perspective, what were the main use cases you guys were thinking about in terms of how this fits into people's lives? I'm thinking about coffee shops, I'm thinking about when at home or when on the go, and what kind of scenarios you were targeting.
Hi, Alice. Thank you for your question, and I can take that. So our target audience was mainly supposed to be diabetics or people who want to reduce their consumption of sugar, because this is supposed to let them taste sugar by activating their sweet taste receptors without having them actually consume sugar. And so you might be asking, we already have artificial sweeteners on the market, and the way that this fits a different niche than artificial sweeteners is that we've researched into how artificial sweeteners has some poor impacts on your gut microbiome. And so we thought if we don't ingest any sugar at all, including any artificial sweeteners, then we will be able to address this issue with artificial sweeteners.
And sorry, just a quick follow-up. So have you been able to talk to people that live with diabetes at all to be able to understand how they might use it in their daily life?
So we haven't been able to talk to like a large group of people with diabetes, but we've talked to a few individuals, and the individuals that I've talked to have mentioned before how sometimes it may be kind of frustrating with how their sugar intake is so heavily regulated and scheduled. And so in our proposal, this would allow them to still taste sweetness whenever they want by using the spoon to supplement any food they want. As long as the food is sugar-free, they're still able to consume it anytime and still consume sugar on their regular scheduled time.
Cool, thank you.
And then just to add on to that, just a little bit in terms of the harmfulness of artificial sweeteners. So some of the artificial sweeteners could actually result in a higher rise in blood level compared to regular sugar and disturb gut microbiome, according to our research. So that's why we're coming up with something to substitute artificial sweeteners in that case.
Thanks, team. Paula, please.
Great, thanks for the presentation. It was very creative. I guess following on Alice's question around the consumer, this obviously would be a significant behavior shift for consumers, right? Because they're used to adding either a sugar or a sweetener for consumption, and now we're saying you use this utensil. Have you thought about what would it take to bring the consumer along? Because this is obviously behavioral change. It would require some education and application, like probably some questions the consumer would say, like, every sip of coffee that I take, I need to have this with me. Like, have you thought a little bit about what would it take for you to get critical mass for consumer changes? Because the impact could be significant, right? Now you're no longer consuming the sugar content, the sweeteners, but what have you guys thought a little bit about, what would be the journey that you'd have to bring the consumer along for them to adopt this?
I can start answering this question. I think I will need Aaron's input talking about more of the design. So we kind of you did brought up a very good point. Like, not every food are consumed with a spoon. Specifically, as you said, like coffee, you are not used to like scooping coffees. So we're more thinking of targeting the more conventional food that we eat for a meal. And then we put specific designs. If you've look at like the spiky design underneath the spoon, we're trying to put ligand layer on top of that. And then we're trying to enhance like how much the ligand layer touches our spoon when we are ingesting the food itself. So we're thinking more of like a regular meal instead of coffee. And do Erin want to add on to the design part a bit?
Yeah, I can take on the design part. Because as we also declare in the video, like we consider this like novelty tableware to simulate diners' full range of scents at the table, because we all know that like sweet, sour, salty, and bitter are perceived anywhere there are taste buds. So this, because of this, we tackle like tactability by creating this like small bumps underneath the spoon, so that we can also create this like strong connection between the spoon and food, and also the taste simulations of around taste buds.
And then to finish off the question of like shifting consumers' behavior, we'll have to again educate them in terms of their health on the health benefit of the products, and also the environmental impacts of reducing sugar consumption and reducing sugarcane production monoculture, and like what the benefit will make. What the benefits are, and like how much impact will it makes for people to willing to take this step forward, I guess.
Thanks, team. Appreciate it.
Thanks, team. Thanks, Paula. Nick, why don't you go next?
Hi, guys. I love the idea. I'm fascinated. I've got 100 questions, but I'll ask this one. I'm interested in understanding a little bit more about the reuse of this utensil. So is there special treatment, and how do you make this convenient for the consumer to be able to reuse without damaging, I guess, the effectiveness of the utensil? Have you done any exploration there?
Yeah, I can answer this. So a lot of this will have to do with further material research and development, but our plan is to make the spoon, like the sugarware, a semi-permanent product, in that it is just like a regular utensil that can be used over and over again, cleaned in your kitchen. And you can also carry it out with you in a case when you're going outside to eat, or you can use it at home. But in our idea, we don't want it to be single use, and we want it to be capable of using again and again, so that we can reduce how much carbon footprint we are putting out to the world.
All right, Sarah, go for it.
Hi, team. Again, fascinating project. The idea is very original. And I have another question for you guys. This is more regarding the different approaches to achieving the same objective. To me, the essence, the heart of your project is the sensorial approach to a sweetener alternative. Have you looked into different methods of activating the taste buds other than attaching these ligands to a utensil? Perhaps in a way that would be more in line with existing consumer behavior when consuming sweet, and also in a way that would give the user more control over how much sweetness they're actually exposing their taste buds to.
So we actually talked about it a lot during our development, like the idea of development phase, with our design member on Broad. They were mentioning about maybe enhancing our smelling or other fillings that when we're consuming the food. But then we want to develop something that's most practical at the moment, and we came up with the spoon idea because we want to maximize the situations or scenario that we're able to use it, and we wanted to fit with most of the food that we consume, and then we felt like limiting it to the sweet taste is going to be most applicable to most of our like scenarios, and not limiting it to one particular food for situations.
Thank you.
Thanks, team. Thanks, Sarah. We are at time. This has been such a pleasure welcoming you all to the stage. Great projects. Super interesting to see what you think the vision of the future is. Thank you again for everything. We are going to move into our first speaker. I'm going to call LinYee up. Hi, LinYee. You'll just give us a wave. Hello.
Hi, everybody.
Students. Hi. It is my absolute pleasure to introduce LinYee. LinYee is the founder and editor of Mold, a critically acclaimed print and online magazine about designing the future of food. Through original reporting, Mold explores how designers can address the coming food crisis by creating products and systems that will help feed 9 billion people by the year 2050. In 2022, she launched Field Meridians, an arts and design organization committed to advancing critical place-based interventions to strengthen food ecologies. She is currently the editorial director of the Emerson Collective and an adjunct professor at Parsons, the New School, and was previously the entrepreneur in residence for Quartz.com. She has written about design and art for Food 52, Design Observer, Cool Hunting, Elle Decor, and Wilder Quarterly. LinYee, we are so excited to have you with us. I'm going to let you take it away. So feel free to share your screen. Perfect.
Can y'all see me and hear me okay? Okay, great. Well, first of all, thank you so much to Alex and Daniel for inviting me to speak today. I'm just so honored to be, in a small way, a part of this Biodesign Challenge. And congratulations to every single person and team and all the judges for making it to the final. This is such a huge thing. The work that you're doing, the way that you're thinking about design and growing the future is so critical. So thank you for letting me be part of it. So, you know.
You might just want to make presentation mode.
Oh, let's see here.
We're just seeing your browser, that's all.
Oh, strange. Okay.
And if not, we're going to go with that.
No, I want you to see my browser. Let's see here. Are y'all seeing my actual? Oh, it's weird that it's. Sorry, I apologize. You can see the browser, but you're not seeing
You're seeing your presentation, or just seeing the top of the browser.
Okay.
So as you go through your presentation.
Yeah, let me get out of here and then see. I can start again.
Sorry, everyone in the feed watching. Technical difficulties are real.
I think I have to. I don't know why it's doing this today. I apologize.
That's okay.
You'll just have to see my bookmark shawl.
Okay.
So, thanks, Alex. I appreciate it. So you might be wondering what this picture is in this presentation, and it's actually a picture of a toilet, and it's a Toto toilet to be exact. And it's from the very first issue of our print magazine, where we had a story about the future of toilets. And so some people might wonder, well, why are toilets in a food magazine? And my argument is, why aren't they in a food magazine? In the same issue, we revisited Dr. Alexandra Daisy Ginsburg's 2009 project called the Scatologue, which I'm hoping that many of you are actually familiar with. And it really, this was 2009. So at this point, over a decade ago. And it proposed a future where people would ingest microbial collaborators that would help diagnose a range of illnesses by turning bowel movements into this kind of color-coded rainbow. And so I'm sharing these two stories because they really underpin two ideas that drive the work that we've been doing at Mold for the past decade. The first is that when we talk about food, we should be talking about waste, point blank. The second is that the web of life is actually a food web that connects human and more than human collaborators. It was in 2011 when I was an editor at Core 77, which is an online industrial design website and resource, when I learned about this incredible project from Philips. And it was a concept called the microbial home. And the premise was that the kitchens of the future could be powered by food scraps and waste. And this project really moved me because the idea was just so poetic. That the kitchens of the future could actually be biological machines, that they could be efficient, closed loop systems. And, at the time, this idea was just so provocative. Here you see that you would do food preparation on this kind of bamboo or like wooden platform. Then you could take the food scraps, put them down the sink, that would then come into this large kind of biodigester. You can see the crank. So imagine that the organic scraps are being kind of broken down, and then the waste gas, methane, that is produced from organic materials breaking down would then be captured to power the light in this kitchen, power the actual stovetop. And, at the time, projects like these weren't really being written about in design publications. And this gap, it really inspired me to found Mold. So in 2013, we launched an online magazine. It was just at the time a place that I wanted to talk about food design. And since then, we've published over 1,000 stories online. We produce exhibition and events. We've grown our Instagram following to over 65,000 people. But it was in 2014 when I was writing about this student design project. It was a poster project by the Australian designer Gemma Warner. And as you can see, it's like an infographic, and it's telling us a story. And that story is actually a warning from the United Nations that was predicting that by the year 2050, if we continue to eat and drink the way that we do today, that we would not be able to feed the 9 billion people that would be on the planet. And this idea completely terrified me. I had never heard of the food crisis. And it inspired me to consider the focus of what we were doing at Mold, both online and think about the urgency of our message. And so as we were thinking about how do we share this news, this story about the food crisis, we thought, well, what better way to reach our intended audience of designers than creating a beautifully designed object. And in 2016, we launched a print magazine, and each issue is a different theme. So the first issue, as I mentioned, was about designing for the human microbiome, which obviously everyone here today is very invested in. And the second issue was about the ways that designing tableware and furniture can create new dining rituals. The third issue is about food waste and how food waste could potentially be a material to power the cities of the future. The fourth was about designing for the senses, but it was also about human-computer sensing, the ways that we understand and experience food through all of our senses. And the current issue is about seeds. And so not only the seeds that we plant in the ground, but also the seeds of ideas that we carry through times of crisis. So for the past decade, as I've dug deeper into ways that design could address the food crisis, I have come to realize that it is not about what we will eat, but how we will eat that will actually safeguard us against the coming food crisis. And this how is a question that all of you are grappling with today, which is, how do we grow the future? How do we design living systems that feed both people and planet? And the question of how is a really unique one for design because it demands new lines of dialogue across different bodies of knowledge: science, agriculture, policy, technology, art, and communication. And how also demands new, ancient, future ways of knowing. And what I mean by that is by asking how, it demands that we recognize that we are actually all very interconnected, that me is actually we. As you all know, at a cellular level, we are composed more of other microbes than we are of human cells. So we are not islands, but we're actually oceans that flow into one another. Asking how demands for us to rethink our relationship with food. The COVID crisis has really underscored how dysfunctional our globalized food system is. And in this system where efficiency alone is rewarded, the crisis has brought up so many questions around our relationship with food, like where does our food come from? How does it get to our plates? How do we design systems that enforce a sense of belonging, a sense of interdependence, a sense of life? One of the things that I learned early in this work is that the average conventional apple at a supermarket in the United States is probably about a year old. And that taste of that apple, when you're biting into it, it doesn't taste like life. It tastes like it's been sitting there for a year. So I believe that asking the how, we can begin to co-create solutions at all scales for building hyper-local, sovereign food ecologies, where communities can have access to culturally appropriate, nutritious, biodiverse, and soulful foods. Eating is really the only thing we do besides sex that engages all of our senses. This multisensory experience that we participate in, often unthinkingly, multiple times a day, demands acts of care. How can we use the lens of our relationship with food, your experience as biodesigners when thinking about care, and our relationship to the often unseen people and more than human collaborators who produce our food to transform the way we experience the world around us? What happens when design moves beyond just form or function into including what I believe should be a third tenet of design, which should be care? After all, as the seed steward Rowan White reminds us, agriculture was the original covenant. We take care of the land, and in turn, the land takes care of us. And in the context of more than human design, we know that soil, oceans, which are the locus of our food production, are also the largest carbon sinks. Everyone here knows that fermentation is an act of care. When we think about preparing and preserving food, the way our ancestors have, the way our future ancestors will, the designer Hashemka, who is based in Jordan, uses digital tools to reimagine the production of jamid, which is traditionally a Bedouin yogurt. It's a salted and dehydrated yogurt that is core to a lamb stew that is the national dish of Jordan. Care can also look like this, which this is a speculative project from the British designers Bert and Nita from 2010, which is 12 years ago. And it cultivates, you can see it's basically a wearable algae farm. And so the idea is that these algal colonies that live within this kind of wearable farm, you form a sort of symbiotic relationship with them where they feed on the carbon dioxide, and then we would then harvest the algae for nutrients, and also because algae is delicious. And, you know, in this photographic series from the photographer Corey Olson that accompanied one of the stories for food waste issue about community fridges. And it was amazing because during the pandemic, at least here in New York and Brooklyn, there were networks of mutual aid that just emerged around New York, Brooklyn, the United States. And what was included in these mutual aid networks were things like community fridges. And I always have to remember and remind ourselves that community fridges are actually a design into our built environment. Design decisions, when we decide to divert things that would have become food waste into feeding people without any sort of judgment, without any sort of preconceived notions of like what people should or should not eat, it allows for a sort of kind of democratic community-based like network to start building and supporting one another. What worlds and perspectives can open up when care is centered as a design principle? And how do practices of care allow us to collectively co-create new possibilities? You know, designers have been focused on systems thinking for decades. And instead of considering the food system as like this linear progression from production to consumption, could we reimagine our food system as a complex network of care and create food sovereignty at this very, very local level? we've been thinking about, or we're basically finishing our 6th and final issue right now. And I've been thinking a lot about our journey. And this quote from the lawyer and activist Dean Spade has been such a place of deep thinking for me. And it says that, by participating in groups in new ways and practicing new ways of being together, we are both building the world we want and becoming the kind of people who could live in such a world together. And I love this idea because I think as designers, we're often engaged in the question of a world building, but we rarely ask ourselves, how do we become the people that would live in these future worlds? And so designers are really uniquely positioned to participate in this specific kind of world building because, we've been given the tools and the education to create beauty, joy by designing with all sorts of different stakeholders. The challenge to me is about designing products that are and resilient systems that enable people not only to feed themselves, but also see themselves as co-creators in this kind of networked food ecology. I love this drawing by an artist named Daniela Fitria Pratono, and it was for a recent exhibition in Kassel, Germany, the 15th edition of Documenta. And Documenta this year was curated by an Indonesian art collective called Ruan Grupa. And I'm going to just put, that's kind of hard with the blur, but this is the handbook that they published, which is kind of like their exhibition catalog. And in this catalog, they talk a lot about how they decided to curate and set up this year's exhibition. And there's a sentence that I'm going to share with you, which is, a collective cannot stand alone, but must purposely play a part in their larger context. Just as in nature, where different species have their specific functions and roles to keep an ecosystem in balance. I just keep going back to this idea and keep asking myself this question. And I'd like to open this question up to this year's Biodesign Challenge participants, which is, what unique role can humans play in keeping our ecosystems in balance? I think oftentimes we talk about these kind of silver bullet solutions for our climate crisis, our environmental crisis. And I ask this question about the role of humans in maintaining the balance, because I think it goes back to what, this idea of care being the third tenet of design, where we take care of the land and the land takes care of us. So understanding that there's this interdependent reciprocal relationship can be a starting place for us to think about new ways of designing or designing less. And so what does this mean for us at Mold? Well, this June we launched Field Meridians, which is an arts and design organization committed to advancing critical place-based interventions to strengthen local food ecologies. And through site-specific exhibition, events, and public programming, Field Meridians is basically engaging my community here in Crown Heights, Brooklyn, to lay the foundations for food sovereignty. Our first project was for the solstice. It's what's called the Solstice Kitchen, and it was a week-long program of cooking demonstrations, free workshops that were basically a provocation for my neighbors. This picture is great because we basically took all of these old kitchen towels and repurposed them into these quilts that we laid out throughout the park where I take my kids every single day to go to the playground. And so the provocation was, we just asked our neighbors, what should the future of food look like in Crown Heights? We had yoga workshops. Our local coffee shop gave out free coffee where we, would boil water with our solar oven. We had this a Chinese American DJ and chef who lives in our neighborhood come and teach people how to make sticky rice, steamed sticky rice packets, which is something that I grew up eating, and she steamed them on our solar oven. We designed and built a mobile solar kitchen, which included a mobile cart you can see on the right, a parabolic solar oven that we ordered on the internet, a solar dehydrator, and a rain catchment system, and a prep table, which all of the built objects were made out of recovered materials from our New York junkyards. And for the week, we really created an open communal kitchen, and it was truly open. Like anyone could walk up and participate. Anybody could walk by and be fed, and anybody could come up and ask questions. And so that curiosity really fueled every interaction, and it opened up conversations that otherwise may not have been possible. I had never cooked on a solar oven before, and I would say the majority of people have never done it. And it just looks crazy. It's like a giant, satellite dish in the middle of our public park. And so coming from a place of provocation, starting from a place of curiosity, just gave us the groundwork to have these conversations and allow people just to imagine new ways of cooking together, being together. And it was incredible. And this project really brought up so much hope, but it also just knit together a sense of belonging in our neighborhood. So as we finish our print magazine and launch into a new space with our arts organization, we're asking a lot of new questions, which include, what does it mean to have a practice that's centered around connection? How do we build capacity for the human condition? How can design cultivate a sense of belonging? How might the concept of emergence, which is this idea that a sum is greater than its parts, be a fertile ground for building new futures? And what are the nodal points where design can affect the most change across a system? It's something that I've been thinking about as design acupuncture for liberation. So as you close out this Biodesign Challenge, I really am just so inspired and so hopeful that we are growing a future that is inclusive, that is accessible, that cultivates a sense of belonging, cultivates a sense of interdependency, and opens up ways of being with one another. And by one another, I really mean both human and non-human collaborators. So my hat to you for being at this point, and thank you so much for inviting me to come and just share more questions than I have answers to. But please reach out if there's anything I can do to support that you're doing. If you have, ideas around some of the questions that we're asking, we really hope that Mold can be a platform for transparency and discussion and ideas. So thank you so much.
Thank you so much, LinYee. I really hope you send the bold manifesto around. It's almost done reading it. It's so fantastic. Thank you again.
Of course. Thank you.
Awesome. I know everyone enjoyed that. That was perfect. Viewers, we are going to move into a short break, little over 10 minutes, and then we will be back on for the second session to watch the non-student finalist teams show their videos, and the judges will come on and do Q&A with those teams. So see everyone in just about 10 minutes. Take a quick break. Bye-bye.
Hi, we're Team Mobius, and our project is on creating a novel microbial chitin PCB. What if electronic waste in production were circular, with the process of decay replenishing the ability to regenerate and derive new material? To begin, we identified an essentially universal electronic component, the printed circuit board, or PCB. PCBs have four main components: the silk screen, solder mask, copper layer, and finally the substrate. The substrate is typically made from toxic epoxy resins and is discarded upon end of life, whereas the other components are typically taken out and recycled. This is an overview of the current PCB production system. As for the PCB waste disposal system, major pain points include the time-consuming and physically laborious process of dismantling PCBs and manually removing their electronic components. The substrate is then ground and dedusted or sorted into metallic and non-metallic particles, which exposes employees to harmful chemicals and fumes. The non-metallic and some of the metallic components are then sent to the landfill, which poses environmental hazards and bioaccumulation in impoverished landfill-based communities. The major component we want to replace in the system is the substrate. The substrate is usually made out of plexiglass or fiberglass and makes up the skeleton of the PCB. Its properties are that it's chemically inert and also an insulator. As for the actual production of chitin, we plan on producing it from lactobacillus fermentation of seafood waste. In order to begin the process, we must first sterilize the seafood shells. Then, we must use heat to kill the DNA samples floating around in the fluid. Afterwards, we can use an autoclave to sterilize the media. Although the autoclave will denature the chitin a little, there's a large percentage of chitin that can still be salvaged after the sterilization step. Why chitin? We decided to use chitin as our base material since it is hydrophobic and has durable mechanical properties. It has a melting point of 300 degrees Celsius, ultimate tensile strength of 80 megapascals, and a 1.8% elongation at breaking. The most common material in PCBs is polytetrafluoroethylene, or PTFE for short, which has a melting point of 315 degrees Celsius, ultimate tensile strength of 20.7 megapascals, and 3% elongation at breaking. Because chitin contains similar properties mechanically to PFTE, we can use it as a substitute. One way we can develop chitin and turn it into a pliable biofilm is to utilize bacteria. Researchers have devised ways to use the bacterial lactobacillus to process shrimp biowaste in a drum reactor and convert it to chitin, which can easily be converted to chitosan. Using this method, we can harvest the chitin from the bacteria as the basis of our biomaterial. Once we obtain chitin from lactobacillus fermentation, we can then use Vibrio cholerae filamentation as a way to promote chitin surface attachment and cross-linking. By mixing these two processes into the same bioreactor, we can then create a system that can develop chitin biofilm on the surface of this bacterial mixture. We can then dry and layer these biofilms together to create a thicker piece to use as our base for our PCB. Although we can use Vibrio cholerae as an initial cross-linking basis, these cross-links by itself will not be enough to maintain structural integrity, and thus we must then coat the biofilm with plasticizer, which we can cross-link with the chitin and make it into a solid-state material. Our substitute will be able to fit in with the already existing method of PCB creation. The other components can be assembled in parallel and with current machinery. Once PCBs have reached their end of life, they need to be degraded. Thus, they are put in a bath with bacteria that produce the chitin-degrading enzyme chitinase. And there are also bacteria in the bath that break down the components of chitin further, creating pure nitrogen among other byproducts, which can be used in fertilizer. However, we cannot neglect other byproducts, for example heavy metals, that have really high negative impacts on the environment. It is imperative that we find a way to deal with it in a safe manner. There are several techniques of bioremediation of heavy metals through fungi and bacteria that have proven to be successful. In many factories, heavy metals are released into water sources or in the soil around it. As these metal particles float down the water source, marine fungi can absorb heavy metal particles and then synthesize those particles into nanoparticles, which can then be harvested and used in various commercial and research contexts. As for the other byproduct, we can integrate those nitrogen spin-offs into fertilizers, which can be used in community gardens and farms and then produce vegetables and fruits to feed the people. Now for our system overview. Firstly, we start from locals producing seafood waste, which is sold to the factories. Next, after sterilization treatment and autoclaving, the seafood shells are dumped into a bioreactor featuring bacteria that convert it to chitin. Afterwards, this solution is transferred to a second bioreactor in which bacteria turn it into a biofilm. From there, the biofilm is extracted and layered and then cross-linked for material strengthening. Afterwards, the PCB substrate substitute joins the manufacture process that already exists and is assembled. The finished PCB ready for use is then integrated into electronics. Upon reaching end of life, it is then recycled in a chemical bath made of bacteria that degrade it into two main components. The first branch of waste product is the heavy metals, which are processed by marine fungi and then translated into nanoparticles, which are then resold back to the factory in isolated conditions. Afterwards, we'll take a look at the second byproduct, which is nitrogen, broken down by the bacteria in the aforementioned bath. That nitrogen is then integrated into fertilizer and back to the farms and to the community through the food chain. Advantages of our system are that it's bio-derived and biodegradable. It also features maximum reuse of material components and waste components, and it preserves and enriches ecosystems. It benefits local communities, and it is also compatible with current manufacturing processes. For future steps, we would test out the biological processes in sequence, gain more insight into how to integrate our system even further into existing infrastructure, and also map out the time-scale compatibility between biological production and current systems. We'd also do analysis for financial viability and look into the potential of using this process for producing other components for electronics like plastics and rubbers.
Indonesia is the largest archipelagic country in the world, with 76% of total area is water, with the longest coastline in the world around 34,000 miles. Indonesia archipelago brought high biodiversity in the sea, but diverse and naturally abundant organisms also comes from the sea, and become a main commodity with well-known quality in the global market. The abundance of seafood has become a source of life far before Indonesia's modern time. It's part of society and culture. However, it left us another problem, especially due to high population numbers: the waste. Indonesia is also awarded as the fourth most populous country in the world, with a total population about 270 million people in density in 141 people per kilometer square. The usage of electronics in Indonesia is significantly increased, brought bigger problems to the environment: undegradable electronic waste. To overcome the problems, we try to connect the privileged geography and natural resource of Indonesia to achieve more sustainable ecosystem. In this experiment, Locus Found would like to fabricate alternative materials of PCB components using sustainable materials such as chitosan from seashell waste, bioresin from pine tree, and fibers from fabric waste. Now we are ready for the steps of PCB fabrication. Preparation of chitosan powder from seashell. Collect the seashell waste. Wash and clean the seashell well. Dry it in the oven to reduce water components. Grind the seashell until become powder. We called it chitosan powder. Preparation of bioresin. Collect the sap from pine tree. Let it crystallize, and the crystallized sap called gondorucum. Put the gondorucum on the saucepan, then melt the gondorucum until it becomes liquid. Preparation of chitosan and bioresin mixture. Add acid to chitosan powder until it becomes liquid. Mix together the diluted chitosan to melted gondorucum. Preparation of PCB material. Prepare the mold. Pour the chitosan and bioresin mixture to the mold to make first layer. Add fabric waste on top of the layer. Pour again the mixture above the fabric waste for the second layer. Let it set and dry. Take out from the mold. And the alternative materials for PCB is ready to be used. The impact of this materials application is hopefully to reduce the use of synthetic chemical based on conventional PCB materials, especially plastics, synthetic chemical resins, and fiberglass, which is harmful to the ecosystem due to the undegradable characteristic. Furthermore, it became a solution to sustainable waste treatment in Indonesia specifically, global generally, and help the nature healing by it. For further information about this project and our team, kindly visit our website on locusfoundation.com.
Hi everyone, welcome back. My name is Veena Vijaykumar. I am the Program Director of Bio Challenge. I am excited to be here. The morning session was wonderful and we're excited to go into this afternoon session with our top 3 non-student team presentations. If you're just joining us and you didn't see our wonderful fanfare in the morning, our top 3 teams are the University of Minnesota Biodesign Collaborative, Crazy Cocos, and Chi-Town Bio. So we're going to start off this session with the University of Minnesota Biodesign Collaborative. Jeff, please play the video.
Hello, we are the University of Minnesota Biodesign Collaborative, and this is our project, Fair Farms. Here's the problem. Rapidly changing peri-urban communities across the globe face unique challenges due to shifting land use patterns, rapid economic growth, and changing demographics, all with cascading impacts on the environment, human health, and well-being. As boundaries between urban and rural environments blur, and agricultural lands are removed from production, connections to local, sustainable food systems also suffer.
This is present in Scott County, Minnesota. This is a site for our Fair Farm model. It's one of the fastest growing counties in the state. Once exclusively rural and largely homogeneous, its population more than doubled in the 2 decades. The county now consists of suburban, town, and rural communities with rapidly diversifying economic, racial, and religious demographics. School enrollment demonstrates this growing diversity. Students in Scott County's largest area, city, speak more than 70 languages, 31% qualify for free reduced lunch, and over 40% of the student body are students of color. According to the local 4-H staff, the county and young people in particular are undergoing an identity crisis in the transition from a rural past to an increasingly urban and multicultural present. As the United States becomes more and more diverse, more and more communities are experiencing difficult transition. Fair Farms asks the question, can the Fair Farms help students and residents from diverse cultural and socioeconomic backgrounds create community, grow food, and promote well-being as well?
Our solution combines 3 existing elements: community systems, food systems, and public resources like county fairs. In urban and rural communities alike, small farms, NGOs, universities, entrepreneurs, and local governments are working to connect food and community in innovative ways.
At the same time, research institutions like the University of Minnesota are working on the profitability and sustainability of food systems through climate-adaptive solutions like passive solar greenhouses and perennial crops. The county fair has a rich tradition as nexus of community, agriculture, and commerce. Our solution imagines fairgrounds as small-scale, farm-based innovation hubs that provide training and entrepreneurship opportunities to young people and members of the community.
A fair farm is a framework for small-scale teaching farms co-located on public lands like county fairs. Co-location makes productive use of land that often sits idle. It also reduces costs and barriers to entry by sharing facilities. A systems approach connecting local resources, that model can adapt and respond to the unique needs of each fair farm community. Fair farms are designed to be up to an acre with space for a small high tunnel and climate-adapted perennial crops. A passive solar deep wind greenhouse can add up to 450 square feet and extend the traditional growing season. Investment in infrastructure is only one part of the fair farms model. The real work begins with establishing the relationships between community members and understanding local growing conditions, marketing opportunities, and unmet needs. This process will identify priorities, governance structures, and strategies appropriate for each fair farm. A phased approach ensures that fair farms grow to meet emerging communities' needs and goals.
Conversations with farmers, researchers, and NGOs revealed both strengths and weaknesses in our plan. Aaron Wills validated the need for small-scale incubators. He also estimated that a 1-acre plot could produce up to $50,000 in revenue. Dan Handine pointed to farmers experimenting with tropical fruits and vegetables in deep winter greenhouses, while Anna Richardson emphasized the importance of leveraging existing infrastructure. Crystal Odom and Ayana Sol Machado pushed us to question our value proposition and economic model, while Joanna Tsenis provided insight into the workforce development programs at local high schools. She also provided valuable information about school and governance that impacted our outreach strategy. In the next phase, we will continue to refine the Fair Farms model in consultation with community stakeholders, build our budget model, and begin researching potential funding sources.
Each member of our team has strong memories of food in our family and community history. We know that food can create powerful connections, and we hope our model inspires others to explore new relationships with their local food systems. Thank you.
Awesome. Wonderful job, U of M Biodesign Collaborative. Let's go right into judges' questions. Judges, if you have a question, please turn your camera on. Yeah, Jacob, please, coming from the leaves. Make sure you unmute yourself too, please.
There we go.
Awesome.
Hi, yes. Thank you for the presentation. One of the questions I had, so kind of looking at this model, what do you think is like the major differentiator between in like I think of like technical ag programs or like community colleges kind of playing some of the role in the community today? So how do you think this kind of concept is differentiated from those programs today?
So thanks. That's a great question. And I think that I don't know if there's a need to differentiate as much as there is a need to collaborate. Some of these programs that exist are doing a great job, but they're also looking for a story to tell, a way of bringing people together around a common cause, and a way to connect people across geographical locations. And Fair Farms kind of provides a conceptual model that could be implemented, say, in Scott County, which is our model, which is just south of the Twin Cities, but also in the upper Midwest, in areas in the along the Red River, where beet production, for example, is a big thing. The other piece is that a lot of these programs seeking to introduce sustainable ag practices and looking for climate adaptation. And the extension folks have a nice window into the traditional agricultural community, sort of the tractors and row crop folks. But there's a kind of a disconnect between those people and the sustainable farming folks. And some of our interviews kind of revealed this gap and the desire to close the gap. And so working with extension through their connections, using the the fair as a locus that is relatable to a wide swath of the population, and then creating these innovation hubs where people can come together, I think builds upon the extension model as opposed to differentiating itself from that model.
Perfect. Thank you.
Yeah.
All right, we'll go to you, Arti, and then we'll do Ivan.
Sounds great. Great presentation, team. Excited to hear more about your idea. I think my question for you is, as you think about the urbanization that's occurring, and you even cited some of the changes between land use, demographic changes, even the socioeconomic shifts. I'm imagining an environment with tremendous amount of behavior change that's occurring at once as all these factors are shifting. So as you think about fair farms and really incentivizing people to engage and communities to invest in this, how do you think about really bringing the community along and having them vested in a behavior change that is maybe competing with many others that are simultaneously happening?
That's a great question. I want to give other members of my team a chance to answer. If not, I can jump in and tackle that one. Since we have a little bit of time today, I'll just kind of jump in. I think one of our goals is to work with school systems and existing 4-H programs. And in some of our discussions, we've discovered that people in our extension 4-H world are looking to establish these small community innovation farms, but they don't really have a conceptual model that works. But there is interest and demand from school groups, from county groups to find ways for young people to engage with the land and agriculture. And so I think the behavior change on that level starts with working with young people and providing them with pathways and jobs that teach them skills in the ag economy and in food production and food innovation. That's one piece. The other piece is opening these avenues up to local entrepreneurs who want to use the fair farms as a place to experiment with new crops or new foods, and then work again with local restaurants and community groups who are in need of food shelves and pantries and Meals on Wheels programs. I will say the behavior change is significant, and one of the reasons we didn't include anybody at the county fair or in local governance in our initial conversations is because of that suspicion around people coming into communities with solutions that are going to be plug and play and not really responsive to their needs. So we want to do a lot more research with small farmers, with organizations that are currently dealing with new farmers from immigrant communities like the West African Farmers Association before we actually go to governments and people who are holding the purse strings.
Yeah, thank you, Arti, for this very good question. Thank you, Michael, for provide this great answer to that. And I just want to add that is the model we will create is we want to build it as a mutual beneficial model. It's not only that the local farmer or the local government could provide support to the incoming community member. The incoming community members, these new immigrations could also provide by using their previous experience, skills and backgrounds and culture to bring back to the local farmer. So in this way, we want to build this, ecosystem to grow in the future. Is that people could get this, and throughout our conversations in preparing for this competition, we always say that we want to use food as a media to empower people. Is that through our programs, by using our model, people can, the local farmer could become a new type of local farmer, and the immigration could become a new type of community immigration. So that is what I want to add here. Thank you.
Wonderful. Let's finish up with Ivan. Please go ahead.
Sure. Quick question, and great job, by the way. What do you think is the biggest challenge for reproducing fair farms in other states and cities, and how do you think it could be overcome or tackled?
Great question. I think that one of the challenges of kind of like reproducing this model in a different environment could be the existing demographic identity. And so I think the way that you can approach that is by taking the time to get to know the community and build, like, figure out what the problem is with the lens of like empathy, and then having a collaborative problem solving space with the community so that you can best cater to that community. And so the model that we provided is a very general model that can be applied elsewhere. But in order for it to work, you have to first work with the community.
Thank you. Thank you so much for the answer. Michael, do you have something to add?
Yeah, just wanted to add two things. I think that one of the things that had an impact on me was a conversation with a group at the Philadelphia Community Farm, which is in Osceola, Wisconsin, and mentioned Ayana. And one of the things she said is change happens at this crust. And I think that really impacted our thinking about this and the kind of very slow pace at with which we started reaching out to people. But fundamentally, I mean, trust and benefits are going to be obstacles. And so our model is really scalable and small. I mean, we're starting with things that we think can be set up for a couple $100,000 in the first year and then operated for even less in subsequent years, with the option of building more. You don't need the deep in a greenhouse. And we want to facilitate innovation through using shared commercial kitchens in schools and other existing facilities to lower costs and to create the space for innovation and dialogue, so that whatever the Fair Farm becomes in Kansas or in California or in Minnesota reflects the local community, its needs, the way it needs to adapt to climate change, and the way its population wants to engage with food.
Great. Thank you so much. Well done.
Wonderful job, team. We're going to move on to keep with time. So up next, we have Team Crazy Cocos.
Chocolate is delicious. Many people globally would agree to this, and it comes in many different forms. It's also a tasty emotional boost for people, especially during tense times, as highlighted by the increase of chocolate sales since the initial COVID lockdowns. But even something as tasty as chocolate is not excluded from having issues. Taking a peek at the supply chain, there are many disparate issues. Despite the large amount of wealth generated from the chocolate-loving world, the cacao farmers at the source of the supply chain are not even getting a fraction of the profit that the industry takes in, with companies knowingly sourcing from farms that use child and slave labor in order to keep prices competitive. Most workers on cocoa farms in the global south still live in extreme poverty and deplorable conditions, many of which are children, and are forced to use toxic industrial pesticides without proper safety equipment. To combat this, organizations such as Fairtrade and the World Cocoa Foundation are helping push government policies and industries to combat these illegal conditions. Mars has taken big steps to phase out some of the poor conditions along their supply chain. However, one of the biggest opportunities for improvement is in the amount of revenue that farmers can pull from their own crops. More income for the farmers means that they can improve their quality of life, have access to better education, not be forced into slave labor, and to use more sustainable methods for farming that don't harm them or their environments. One of the most pressing environmental issues in the supply chain is the amount of discarded cocoa husk waste. The outside of a cocoa pod is a robust, fibrous husk covering the fruit and beans. After the husk is removed from the beans, they're roasted and shipped around the world to produce our chocolate. Everything else is scrapped and left to rot on the farmer's property. Roughly 30 to 40% of cacao farmer income is spent on pesticides and fertilizer for their nutrient-deprived soil. Research suggests that these festering piles of cocoa pod husk waste, or CPH for short, are supporting the growth of cocoa diseases, such as black pod fungi and witch's broom, which are devastating to the farmers' cocoa crops, and therefore push these farmers deeper into poverty, as they can't sell these infested beans. The rise of these plagues' destruction means even more harmful pesticides are used to protect the crops. With so many cacao pods wasting, could it not be used for something? Well, it very well can. There's a whole range of possibilities based on several research papers. We'll focus on two that demonstrate the most potential for scaling to farm use in order to present a solution that addresses these two issues: CPH waste and the impacts of pesticide damage on both the workers and the environment. Additionally, it could be scaled to sold internationally. The first is using the husks to create a biofertilizer. There's a small number of farmers already using these methods to create fertilizer from the husk, though it hasn't been scaled up to be utilized more widely. We believe that not only could this be a source of income for farmers during a moment where global fertilizer supply chain issues have arisen, mostly due to the Ukraine-Russian war, but also as a means to combat regional crop diseases and to protect the workers from the damaging effects toxic industrial chemicals and the pesticides that are being used currently. In the study, a microorganism is inoculated into the pod husk waste and grows as the husk decomposes. Once the husk compost is implemented in the fields, the microorganism has been shown to enhance the effects of counteracting prevalent crop diseases such as black pod. The result is a fertilizer that can not only enrich the soil, but also combat the spread of plant diseases without the use of harmful pesticides. We tested this study by adding yeast to a sample of fresh cocoa pod husk. Yeast has been discovered to have properties that counter the witch's broom disease that's been affecting many crops in Latin America. Though there are specific microorganisms that can be used for each specific region and their local plant diseases. This process also has the potential to be used regionally. Although it's not ideal to transfer the plants across continents, these biofertilizers can serve regional and neighboring countries. One example would be if the Ecuadorian farmers sold this fertilizer to Brazil, who serves as the world's biggest importer of fertilizer and has been hit hard by the supply chain issues caused by the Ukrainian-Russian war. This also means that the bioorganisms can be specific per region, ensuring control over invasive organisms being introduced into different environments.
We propose that Mars could lead this educational and resource campaign with its cocoa partners to address the issue of CPH waste and toxic pesticides. With the proper knowledge provided by Mars's partners, farmers can transform their husk waste into useful products that are now being demanded globally. We also encourage Mars to allow the farmers to receive 100% of the profits from the fertilizer they sell, which will prevent the chocolate industry from exploiting them further.
Awesome. Thank you, Team Crazy Cocos. Let's go right into questions. Judges, do we have anyone that wants to go first? Yes, Ivan, and then Beth.
Hi, Crazy Cocos. Nice to see again your video. Have you, as I understood, the idea is that the local producers use the husks for making the fertilizer. Have you thought about the willingness of the farmers to engage on that process? And also, have you thought about better thinking on a solution when you can insource that waste material and you treat it is in a centralized way where you can produce the biofertilizer and just give it to the consumer, so they don't need to be doing it directly. I'm curious to understand your thoughts about it and what challenges do you think it will bring, giving the process and technology to the farmers.
Yeah, so I can take this one, I guess. A lot of the farms that we're looking at were more smaller scale. So we were thinking of more on a local scale rather than industrialized, big scaled up version of a fertilizer producer. And most of the farms right now that have the CPH waste is just taking up so much of their property, and it's become a huge toll on their ability to farm, and their crop yields that are being affected by all these funguses and
parasites that have been shown to grow out of the cocoa pod husk waste. So we were thinking that it would be ideal for the scale to be with the individual farmers, because they are the ones being affected by the waste, and then their crops are in turn being affected by the plant diseases, which affects their livelihoods, not only, the company's profits. So we were thinking that for your question about, the incentive to get rid of this waste on their farm, the incentive would be because they have this huge issue, and also because we were looking at the supply chain issues of Ukraine and Russia war, and Russia has been a huge supplier of fertilizer throughout the globe. So now there is like a real need for it. So not only do they have like their personal incentive, but also a niche, or there's a demand now for this product. So it would make sense for them, for their farms personally, to get rid of the waste, and also economically to fulfill that need globally and maybe make extra profit for their farm.
Thank you, Greg.
Add in briefly, real quick. It's really great. It would depend on what further research would need to be done on their actual regional thinking, depending on each farmer. But this is one proposed solution to reusing the husk. Ideally, there'll be other alternatives to reuse their husk waste, but again, regional outreach in that case.
Got it. Thank you, Nico.
Beth, please go ahead.
Great. Thanks, guys. Really interesting concept. What type of education or tools might need to be provided to the farmers to be able to execute this idea? It seems like I love that it's so localized and specific to the farms and reduces the need to transport things back and forth. But I assume there's a bit going into the process to do something like this. So what types of things might they need, and how did you guys think about that in this context?
I can take this. I can take this one. Okay. So we actually taken a look about the educational background and the weather, what kind of climate we're dealing with, because it was important for us that we can actually make this fertilizer in a kind of a DIY scale. And that would then take a basic bioeducation to the farmers, which would be beneficial for them, but also from our end, creating just accessible DIY booklets of step-by-steps of how to do that, but also learning specific needs of their specific farm, because some fungi are more prominent in one area to another. So just kind of focusing on this specific farm's need or regions was important for us.
Thank you.
Anya, go ahead.
Hey, team. Great to hear about your project. I have a couple of questions that are somewhat related to each other. The first is, did you have a chance to speak with any farmers, kind of about your project, about your proposal?
I can take that one, but we haven't spoken to any farmers as of yet, but we know that these practices of making fertilizers do exist. We did take a look at a couple of booklets that were being handed out to the farmers, but as of yet, we haven't spoken to any ones.
Okay. Yeah, and that kind of touches on the next question I have, which is around the process. So kind of bring me deeper into the process of making this fertilizer from the husk. What kind of equipment would you need, and what would that look like kind of on these farms?
Right, I can take this one, y'all. So we're thinking, again, since it is meant to be more accessible, there doesn't need to be a lot of headway with equipment or anything in that regard. We're hoping that with any partnership with chocolate companies, they can provide some aspects such as the yeast, as well as the bioresearch that we've also might be needed. We are also intending maybe that the bacterial input that will go into the compost might come in itself, sterilized containers, because it is difficult to have a sterilized environment. But again, we were thinking more of like budget equipment. And as we were working in the lab, we were working within constraints such as that, so that it can be done in, ideally anywhere. Of course, there are restraints. And again, that would go into further depending on the bioorganism that's being implemented. Since we only work with yeast, it's more room temperature and sugars and such. So that one was a bit easier to work with, but it can still have a wide usage, at least in Latino America, for Wishless broom, which is something that affects a lot of cacao plants.
Okay, I'm leaving it open to judges for one more question. Anyone? Yeah, Harpreet, please.
Hi, team, again. Good presentation. Congrats. I have a question, actually, and that's related to the very first question that you got. I will use an example here. Some farmers produce compost on the site that they are farming at, and then they use it. Others might get the compost removed using collection agencies. In your specific context, what would work best and why? Why would the farmer need to do this, or why not?
That's open-ended. And so if farmers ideally want to use it for their own crops, that's ideal. But we were thinking that it can also be, if they want to begin selling it for income, for revenue as an additional resource, they can go through a third party, a collection agency, and actually have it distributed to other local or regional areas. Again, we're thinking keeping it local and regional because if we're making like a biofertilizer, we don't want to be crossing any bioorganisms like internationally. Ideally, it's within the local environment. So if farmers would like to expand it into a small fertilizer business, they can, again, open-ended. We're thinking along lines of that so they can actually generate more wealth. Because from our research, having more education and a better source of income will increase all their aspects of life. And that's really the end goal, is to help the farmers.
Thank you.
Awesome. Wonderful job, Team Crazy Cocos. We're going to move on to our last team of this session, which is Chi-Town Bio.
Chicago is a dynamic and bustling city with a booming economy and vibrant population. It's an amazing place to work, live, and visit. However, it's not without its problems. Regions of the city have gone through phases of growth and decline. This has led to a city layout with a relatively high density, yet a patchwork of abandoned, unkempt urban spaces. This patchwork of residential density combined with industrial and transportation infrastructure has left many abandoned spaces with degraded and often contaminated soil, filled with lead and other toxic heavy metals. These abandoned lots damage communities by increasing a sense of isolation as well as creating a feedback loop of neglect and disinvestment, lowering property value and increasing local economic struggle.
One time-tested method of reinvigorating small urban spaces is the Miyawaki method. This system of densely propagated native plants in relatively small spaces was developed by Japanese botanist Akira Miyawaki in the 1970s to restore native forests around the world. The method has been shown in scientific studies to restore local insect populations, improve soil health, reintroduce local plant species, and provide a haven for migratory animals, of particular interest to Chicago, a key stop on one of North America's busiest migratory bird pathways. The Miyawaki method relies heavily on native plants. These plants need less care and resources because they are acclimated to the regional climate and environmental conditions. They also have been key resources in the evolution of local fauna, important for maintaining dwindling populations of local insects, birds, and other animals. Plants in Chicagoland have been essential not just for the regional ecology, but have also provided sustenance for indigenous peoples and cultures, with many plants such as the juneberry, persimmon, pawpaw, walnut, sunflower, and many more providing useful ingredients to any Chicagoan's pantry. Using the Miyawaki method to create dense, indigenous, plant-rich miniature forests will provide an important tool for restoring natural areas, but they will also create important landmarks for often neglected communities.
In order to highlight the potential benefits of these densely packed hyper-regional parks, we decided to create a highly nutritious snack bar using native plants to highlight their potential benefits as food sources for their communities. Plants we include in our recipe include locally sourced pawpaw, the American Midwest's largest indigenous fruit, amaranth, a native grain revered for its high nutritional density, cranberries, a delightfully tart treat native to the upper Midwest, as well as various local seeds and nuts including sunflower seeds, pumpkin seeds, and black walnuts. In our initial recipe, we also used store-bought persimmons and apples for the sake of ease in collecting ingredients. But we plan on replacing these with local cultivars of persimmons and indigenous crab apples and hawthorns that can be grown within our local lots. Instead of imported sugar, we used locally sourced maple syrup as our sweetener, which can be eventually collected from our small lots within the city. To create a starch base for our snack bars, we popped amaranth seeds to create an inviting texture. We then added a puree of apples and our maple reduction, as well as a lightly toasted mix of seeds and nuts to create the base of our snack bar. After baking our bar to create a desired texture, we then slathered our nutritious base with persimmon and walnut to create a gooey but textured fruity center. Lastly, we covered the snack bar with a sinfully indulgent mix of pawpaw puree and maple syrup reduction to give our snack bar a glaze that would delight any sweet tooth. Our final product is a truly delicious snack bar that is full of nutritious indigenous plants as well as a heaping scoop of potential. This bar can be used to illustrate the resources that can be grown within just a small city lot, but it can also be modified to highlight other local plants and crops such as juneberries, raspberries, and hazelnuts.
The purpose of our bar, Sprouted, is to highlight how local plants can be of use to Chicagoans. The lots planted in Chicago using the Miyawaki method could benefit not only hungry snackers, but also local soils, migratory animals, and communities looking for innovation and restoration. The snack bar highlights how native plants can be used to make nutritious snacks while also working to ecologically restore native plant regimes. By making products from native plants, we also hope to highlight the need for and benefits of local agriculture relying on local plants. While our initial plans for designing these spaces may seem small, the implications of local microforests have real impact on the macroecology of our region. These spaces provide sanctuary for local species, which is essential for the eventual restoration of Midwest ecologies. Our success in Chicago can hopefully be a testament to the power of these tested methods in restoring ecosystems in our region, country, and eventually the world. Thank you.
Awesome. Wonderful job, Chi-Town Bio. Let's start with Sabria, already ready.
Hi, Sprouted. Thank you so much for that presentation. I have 3 questions. One, which is hopefully very quick. The first one is, I just kind of want to know what the bar kind of tastes like. And 2, as you think about building out these lots in a variety of communities, who is going to be the steward of taking care of the growth of the plants? Is there kind of a, like I said, like a pointed person? Because I can imagine that there could be overgrowth, weeds, things like that. And then 3, I imagine that this is a seasonal project because as the months get colder, is there thoughts around what then happens to the lots and or how work can be done when fruit isn't growing or, like I said, when it gets colder?
Hi. Those are all really great questions. I'm going to leave the how things tasted to the people who had some of the last batch. In terms of, I'm sorry, could you repeat your second questions, please?
Yeah, just who would be responsible for taking care of these lots? Oh, if you put them in a variety of communities.
Funny enough, one of our team members actually got really excited when we decided on this idea and ended up starting a member-owned, self-driven nonprofit, which is basically like a co-op with nonprofit rules, or vice versa, depending on how you do your paperwork. And then they're actually working with the city to get certified as being a land conservation trust. So that organization would act as the initial impetus for work, but then the goal of having it as a co-op means that people from the community can become integrated in, and at some point, this organization will be able to step back and no longer be like, we're just there to start things. We're not there to take things over.
And then would the same organization be responsible for, like I said, in the colder months, I'm assuming, what happens or what you thought about?
Interestingly enough, some of the things that are grown or used for the bar, for instance, are actually in this region are actually cold weather plants. So, for instance, the American persimmon is generally going much further into the season than a lot of the other stuff, and that's the same way for like a lot of the nuts. Maintaining the land and taking care of it over the winter, though, is just a standard crucial process.
And to add to my teammate's response and addressing your other questions, Sabria, as far as the taste of our bar goes, I would describe it as being close in taste to one of those typical health bars, more on the nuttier side. One of our teammates actually noted that the pawpaw combined with maple syrup has an almost chocolatey taste to it, which is quite interesting. So you get surprises when you start to mix native foods that a lot of Chicagoans don't even get to try that often. So that's just something to note. As far as winter usage, even though we may not have fruits or the food sprouting up during the winter, that is an opportunity to encourage the local community to engage in even fermentation projects or canning and try out new recipes. Our bar is more of a way of attracting people to initially come to our garden, and then we very much encourage for the future that they try out their own experiments during those winter months and during other times of the year.
All right, let's move on to Jacob, please.
The bar looked delicious, so I'm sure it was good. So one of my big question that I had, so I love the idea. I think it has so many potential benefits across different streams, just for deserts and just having green space around as a quality benefit of life. But you also, spent a long time talking about the food benefits. One of the items you hit on in your presentation was the presence of toxins and contaminated soils in these urban lots. Have you thought about what types of testing or what levels of soil remediation would you be willing to conduct in a setting, just to ensure that these toxins weren't potentially being uptaken by the very food that you're giving these communities?
Yes, I can take that. So phytoremediation is the term for what we would be engaging in, and this is a fairly standardized practice at this point, which is using organisms, specifically photosynthetic or plant organisms, to pull the toxins out of the soil. And so this is a great way for getting rid of heavy metals and like lead or zinc or nickel, or basically all of the other things that come from the industrial process stream. And like I said, it's very standardized. And so we would do regular testing just to vet the sites initially, and then decide how much work is necessary after that.
Yeah, to kind of piggyback off of Gabriel, so our case study, that lot is in Garfield Park. So our kind of next step that our team talked about doing is going to this site to take soil samples so we can begin those tests to kind of get a feel for what kind of work would need to happen next.
Great, thanks.
Anya, please.
Hello. Like your ambition here. Looks like you got big ideas. You want to change the world. And I'm really in support of exploring indigenous foods and kind of like supporting this urban foraging sort of a kind of like environment. My question is around kind of like challenges and like, it sounds like things are moving forward with the foundation. What do you all foresee as being one of the like biggest challenges to implementing this at scale? Like actually following through and getting it all done. And there could be multiple answers here from different.
I'm probably the worst person to ask because I'm actually very positive about this. I've been kind of paying attention to what's going on with how steps have moved forward, and everything is extremely well laid out. And Chicago itself actually is supporting this thing. Back in 2021, they started an urban gardens thing where the city was giving money. If you are a land conservation trust, the city will give you land. And these are all areas that are in not great neighborhoods, and due to it could be crime rate or just general location or something else, they're not in the funnel for gentrification, which is actually an okay thing. We don't want to do that to these neighborhoods, but it does mean that there are a lot of pieces of land that are just not taken care of. And so the city and the nonprofits that are already in the city are actually eager to help with this process. They want to move this along.
Yeah, to also kind of speak to your question, in terms of probably the largest challenge, I mean, getting just sort of city support in terms of people who say, like other group members who don't actually have a registered nonprofit, but would want to actively have access to these lots. In some of our research, we looked at a plot of all of the different lots that are vacant in Chicago alone, and there's over 32,000 lots. So I think really just being able to make the right connections within our government to determine who can start to sort of slowly use these lots instead of just continuing to have them sit in isolation.
And a final note, as far as challenges go, definitely adding to what Madison and Gabriel said about just community engagement. We know that the science for remediating these plots and for getting really delicious food out of them, it's all about just getting all the stakeholders really invested and paying attention to it. And luckily, we do see positive signs. Our own team members actually went out to one of these plots and spoke with many of the residents near there, and they were all showing quite a bit of enthusiasm and saying that this is exactly the sort of thing that their community needs. So there is definitely a demand that should ease any concerns over that community engagement challenge.
Thank you.
Yeah. Let's finish up with one more question from Jess. Please go ahead.
Hey guys, really inspired by this. And I think my question is more of a question that stems from curiosity. And that's, Gabriel, you mentioned crime. A lot of these areas are abandoned areas, graffiti, gang activity, crime. I'm curious, one, it sounds like you've thought about that. You probably don't have a big solution, but I'm curious, in engaging some of the communities, you said there's already pull for this. How are they going to address the issue of safety?
So the level of lack of safety in any city is a sliding scale. It's a gradient scale. And so there are some areas that are just not places that you would initially start. But a significant number of the areas that are being addressed in this particular thing, or in this city in general, are not as, they're not, like, to say that there's crime there is not to say that they're not safe or that it's actually dangerous. A lot of this is just poverty driven crime. It's not gang violence. It's just the symptoms of a fractured and alienated community. And so the people who are there want to be connected. They want to have, a third space that they can go that isn't like defined by anything, where they can just be a neighborhood. And I think that type of thing is actually just the type of thing that these neighborhoods need.
Great. That's actually what I was kind of hoping to hear.
Yeah, one last thing to say about your question, which it's great because we've definitely sort of considered how to address that, is one of the organizations that's a nonprofit that our team has relationships with and has talked with is Plant Chicago, which is in Back of the Yards. And through sort of talking with them, a lot of our questions were around, how did Plant Chicago get started here? What kinds of maybe pushback have you received from your community? And it goes exactly to what Gabriel just said. There's been a really sort of positivity around these spaces because they provide resources to these neighborhoods that are in food deserts and don't have access to these kinds of crops.
Okay, thank you, Team Chi-Town Bio. We're gonna move right along. So if y'all could turn your videos off, I'm gonna introduce our next speaker, Nicholas Christakis. So Nicholas, as you get ready, I'm gonna read your bio very, very quickly. So Dr. Nicholas A. Christakis is the Sterling Professor of Social and Natural Science at Yale University. His current work focuses on how human biology and health affect and are affected by social interactions and social networks. He directs the Human Nature Lab and is the co-director of the Yale Institute for Network Science. He was elected to the National Academy of Medicine in 2006, the American Association for the Advancement of Science in 2010, and the American Academy of Art and Sciences in 2017. Dr. Christakis is the author of over 200 articles and several books. His most recent book, Blueprint: The Evolutionary Origins of a Good Society, was published in March 2019. Thank you very much, Nicholas. Please take it away. Make sure you unmute yourself.
Thank you for having me, and give me one more minute to get the slides sorted out like we did on the tech check. So Absolutely. Let's just make sure I can get this to work. Let's see, share screen. Share. Okay, so you should be able to see my screen now, and let's get this thing moved over. All right.
Nicholas, is there any way you can go into full screen mode? We can kind of see your top bar.
Yeah, there's no way I can easily fix that.
That's okay.
So you just see where it says PowerPoint. Is that what you're seeing?
Yeah, that's okay though. We can see it clearly.
Sorry about that. Well, thank you for that introduction. I caught the tail end of the last 2 or 3 presentations, and I know a little bit about what the Biodesign Challenge is all about, and I'm very grateful to be present with you today. I'm going to talk to you a little bit about social networks, and some of these ideas may be relevant as you implement and enact some of the things you're doing going forward. So human beings are embedded in social networks. And these networks obey very particular biological, psychological, sociological, and mathematical principles. And taking this into account offers great opportunities to gain new insights into our behaviors and also to change them. We can use an understanding of social network structure and function for good, to intervene in online and offline networks in order to enhance our health and well-being and advance other public policy objectives. And in the broadest sense, taking human embeddedness in networks seriously shifts our focus to what is known as the externalities of interventions, engaging in the study of the response to treatment among the untreated, not just among the treated. When you go into a population and you intervene in a group of people, it's not just about what they do, it's about what everyone else around them does as a result of your intervention. So, I'm interested in real social networks, the kind we humans have been making and embedding ourselves in for tens of thousands of years, and not just the recent online variety. Real social networks look like this. Every dot is a person. Every line between them is some kind of relationship between two people. Who's neighbor? whose sibling, whose spouse, whose friend, whose coworker, for example. And these networks are, to my eye, intricate things of beauty. And they are so elaborate and so complex and so ubiquitous, in fact, that one has to wonder, what purpose do they serve? Why are we embedded in networks? How do they form? How do they work? And how do they affect us? And I've spent coming on 20 years researching how and why human beings form social networks and how they affect our lives, our health, our desires, our feelings, our thoughts, and our actions. Now, part of this work has involved exploring the biological predicates and consequences of social networks and the evolutionary basis for social network structure and function. I'm going to give you just a quick taste of that because I think it's interesting. The fact that we make networks is very distinctive to our species, not unique in the animal kingdom, but very distinctive nevertheless. In order to understand a little bit about what we're going to be talking about today, it's important to put a couple of basic ideas on the table. Here is a real social network of young people. Every dot's a person, and the lines represent friendships between the people. And what you can appreciate or should appreciate is that different people can occupy different structural positions within the network. So there are different locations within this graph. And we can quantify this in a number of ways mathematically. The three simplest ways are shown on this image. For example, if you look at node B in the upper left and node D on the far right, you see that they have different numbers of connections. This is known as the degree of a node. B has 4 connections. D has 6 connections. And this typically is something people know about themselves. People know how many connections they have. But we can also see that there are other properties of networks that people might not know about themselves. For example, look at nodes C and D. C is in the middle, D is on the periphery. They both have 6 connections. But we, with this bird's eye view, can see that C and D are very different. And I can cultivate this intuition in you by asking you, who would you rather be if a deadly germ was spreading through the network, C or D? And you should have the intuition that it's better to be D. D's on the edge of the network. They're going to be less likely to get whatever's spreading. Or if they get it, they're going to get it later in the course of the epidemic. Now, who would you rather be if a juicy piece of gossip were spreading through the network? Or if you had lost your job and you was looking for a new job? It'd be better to be C. This is known as the centrality of a node, and this can be quantified mathematically in a number of ways. Finally, if you look at on the far left, nodes A and B both have 4 connections, but the difference between the two is that A's friends are connected to each other. They're friends of each other, but B's friends are not friends of each other. This is known as the transitivity of a node, how interconnected are the individuals within a group, and this can affect a whole host of outcomes for individuals, how connected their friends are to each other. One of our earliest projects was to do a genetic study of this using something called a twin study design. And some of those results are shown on this slide. On the y-axis is the percent of the variance explained, or the heritability of these 3 properties I just introduced. And on the x-axis are the 3 properties. On the far left is the number of ties a person has, or the degree. And we see that 46% of the variation in how many friends people have can be explained by their genes. Now, this is not very surprising, actually. Everyone knows that some people are born shy and some people are born gregarious. People vary in their intrinsic taste for friendship. But we also found that some of the higher order properties can also depend on people's genes. For example, on the next bar over, 47% of the variation in transitivity can depend on a person's genes. This is a very bizarre result, one of the more bizarre results that come out of my lab in the last few years. Because what I've just told you is that if you have Tom, Dick, and Harry in a room, whether Dick is friends with Harry depends not just on Dick's genes or on Harry's genes, but on Tom's genes. Whether, you two of you are friends with each other depends on a third person's genes. How can that be? Well, we think people intrinsically vary in their probability of introducing their friends to each other. Some people knit the networks around them together, and some people keep, their friends apart. You can think about planning wedding seating arrangements and how you might go about doing that. Anyway, the base, and even 29% of the variation in your centrality, as shown on the far right, can depend on your genes. The basic point is that the fundamental reality of our desire for connection and our susceptibility, for example, to social influence as a result, has always been with us. And where you are in the sort of vast fabric of humanity depends in part on your genes. And across evolutionary time, it seems that the benefits of a connected life has outweighed the costs in our species. Now, if social network structure has genetic antecedents and significance, it begs the question of how ancient this structure is, or whether we could document such structural features in human populations living in non-modernized settings. In other words, if we could do a thought experiment and go back 10,000 years and map the networks of the people then, if something about networks is evolutionarily shaped, those networks should look like ours. Now, of course, we can't do that, but instead we hit upon the idea of mapping the social networks of the Hadza hunter-gatherers. This is a population that lives in Tanzania around Lake Eyasi. They live in our ancestral environment in the ancestral way. There are only about 1,000 of them left. They hunt and they gather for their food. They have no material possessions to speak of. They sleep out under the stars. And what we did is we made a photographic census of all living adult Hadza, a kind of Hadza Facebook. And we printed it on posters and we took it into the field. And every time we encountered a Hadza person, we asked them to identify their friends in a variety of ways. And then we mapped the social networks of the Hadza. And what we found is that the Hadza social networks, mathematically and visually, look just like ours. So despite the fact that in the intervening 10,000 years, we've invented agriculture, we've invented cities, we've invented telecommunications, the fundamental way in which we go about connecting ourselves into networks appears not to have changed, consistent with its partially genetic basis. Now, while we were mapping the networks of the Hadza, we also asked the individual respondents to play something known as a public goods game. This is a formalized economic an assessment of people's altruism. How nice are people? How cooperative are they? How willing are they to make a sacrifice for their social connections? And we quantified this using real resources, and the dots here, the size of the dot and the color of the dot indicates whether people make a low, medium, or high donation to their friends, to their community. Are they altruistic and cooperative, or are they mean-spirited and what is known as defectors? And if you look at this image, you can see that the cooperative, nice people are clustered, and the mean defectors in little red dots are also clustered together within this social fabric. And in a parallel and early stream of our work, using both observational and experimental methods, we and others provided evidence that a variety of behaviors beyond germs, which we've all now encountered with the COVID pandemic, spread within networks, beyond just pairs of individuals, via processes of social contagion. So obesity, smoking, drinking, and drug use behaviors have been shown to spread from person to person, and person to person to person, and person to person to person to person. And also emotions like happiness, loneliness, depression, and altruism can spread. And crime and voting behavior and purchasing behavior and ideas can be shown using observational and experimental data to spread. People's attitudes, decisions, and behaviors depend in quantifiable ways on the attitudes, decisions, and behaviors of others to whom they are directly or indirectly, friends of friends, connected. And a key idea about networks is that networks magnify whatever they are seeded with. Networks magnify whatever they are seeded with. If you put something into a network, it functions like a social magnifying glass. But networks are agnostic. They will magnify Ebola and violence and fascism and fake news. But equally, they will magnify love and kindness and happiness and ideas. But they don't give rise to those things on their own. Some external force has to start the process going, and then the network makes more of it. Now, of course, there's more going on in social processes, as you can easily imagine, than the social contagion that I just alluded to a moment ago. For example, in the case of the contagion of obesity, my weight gain might cause my friend's weight gain, which might cause my friend's friend's weight gain. There are a number of possible, mechanisms or things that might be happening. One idea is that truly it's contagion or induction. My weight gain causes my friend's weight gain, and that keeps spreading. A kind of social domino effect. But another possibility is that it's not my weight gain that causes your weight gain. It could be that birds of a feather flock together, or homophily, which is Greek for love of like. Maybe I connect with my friends because we have a similar body size. That's why we became friends, or a similar interest in food, or a similar interest in exercise. And so we preferentially form attachments with similar individuals, and that's what gives rise to the process of similarity and clustering, for example. And the third possibility is that it's not that my weight gain causes my friend's weight gain, nor that I and my friend form connections because we have similar taste or body size, but rather that we share an exposure to a similar context, like a gym, that makes us both gain weight or lose weight at the same time. And if you think about it, many social processes and many of the kind of marketing efforts, including social marketing efforts that you're engaged in, have similar kinds of outcomes. Why are you buying an iPhone? Are you buying an iPhone because your friends are buying an iPhone? Do technophilic, Apple-loving consumers preferentially form attachments to each other? Or is Apple's marketing campaign exceptionally good, and that's why we are all buying iPhones at the same time? Or why are our children studious? Are they studious because their friends are studious? Do the studious, nerdy kids preferentially form attachments? Or do they have a charismatic teacher that's making all the students wish to be studious? And all three of these are typically present in any social phenomenon, and so you have to use a variety of econometric or experimental methods to tease them apart. And that's sort of what we've been doing for the last 10 years. So these last 12 minutes, I gave you an overview of like 10 years of work up until about 10 years ago. And now I'm going to transition to showing you some experiments we've been doing over the last 10 years to kind of really understand deeply what happens in social networks. Here's one early experiment we did to isolate social contagion. We took groups of college students who were strangers to each other, and we brought them into a lab, and they were randomly assigned into groups of 4 people. A, B, C, and D, for instance, is group 1 at the first time point in period 1. We gave them some money, and we told them that they're going to play a public goods game. We said to each person, you can give up some of your money, you can give $1 to the group, and if you do that, we will double the dollar and divide it amongst the 4 people. So each person gets 50 cents. The group as a whole has become wealthier, $2, but you gave up $1 and only got back 50 cents, so you had to pay a price. You should probably intuit that the best thing is for everyone to give maximally, that everyone doubles their money. But of course, each person is going to be tempted to be selfish and defect and not contribute and hope that everyone else contributes. So we had them play this public goods game across rounds. So they played one round, and then a bell would ring, and then they would play another round, and then with different people, and then a bell would ring, and then they would play another round with different people, and so on. And as a result, we could create simple linear networks of sequential interactions, as shown on the right. And what we found is that the effective altruism could spread across people. Specifically, if you look in the cascade that's highlighted in red in this image, if Eleni is kind to Lucas in period 1, Lucas is kind to Erica in period 2, Erica is kind to Jay in period 3, and Jay is kind to Brecken in period 4. And this is another one of the most bizarre results that come out of my lab in the last few years. Because what I've just told you is that how Jay treats Brecken depends on how Eleni treated Lucas, even though neither Jay nor Brecken ever interacted with or saw Eleni or Lucas. How some of you listening to this lecture treat each other depends on how others of you are treating each other, even though the first pair might never have previously met the second pair or know them at all. So this is a kind of pay it forward phenomenon, here shown experimentally, the social contagion of goodness, if you will. And this geodesic through the network spread of kindness is distinct from the temporal persistence of kindness that's highlighted in yellow. In other words, if Eleni is kind to Lucas, he learns to be kind, and then he's kind to Erica in period 2, and Lysander in period 3, and Bemi in period 4, and so on. In fact, if you fold back all the extra money that accrues, for every extra $1 that Eleni gives Lucas, 2 more dollars are produced throughout the network. The network functions as a kind of matching grant, doubling the return on everyone's investment. And functioning as a social magnifying glass. Now, to be clear, we're affected in another way by social networks. It's not just what's happening around us that matters. The actual structure of the network also matters. Think about these two objects. As you all learned in high school chemistry, they're both made of carbon. And on the left, you have graphite. You connect the carbon atoms one way and you get graphite, which is soft and dark. Or you take the same carbon atoms and connect them another way and you get diamond, which is hard and clear. And there are two key intellectual ideas here. First, these properties of softness and darkness and hardness and clearness are not properties of the carbon atoms. They are properties of the collection of carbon atoms. And second, which properties you get depends on how you connect the carbon atoms to each other. Connect them one way, you get one set of properties. Take the same carbon atoms and connect them another way, you get a completely different set of properties. And similarly, the pattern of our connections among humans, among individuals, affects the properties of our social groups. It's the ties between people that make the whole greater than the sum of its parts. In fact, new properties such as cooperation and violence, or health and happiness, or innovation and productivity can emerge because of the connections, because of the ties between people, whether they are students in classrooms, or members of communities in Chicago, or workers in firms. It's how they're organized that can give rise to these properties more than who the people are themselves. So it's not just what's happening in the people around us, whether they are altruistic or gaining weight or happy, for example. It's the actual structure of the network that also matters to the outcomes that we as individuals and groups experience. Now, one of my favorite examples of this was some work done by a scholar by the name of Brian Utsi. Brian, for years ago, became unaccountably interested in the success or failure of Broadway musicals. And he put together a data set of 326 Broadway musical production companies. The actors, the directors, the musicians, the producers, the designers, and so on, the people that were putting on a show. And then he computed something very similar to the transitivity that I mentioned to you earlier, known as the density of the network. And I can illustrate that with these cartoons. So on the far left, you have 6 individuals. There's one in the middle and those other 5. And those 5 people are not connected to each other. There's no transitivity here. And in theory, there are 5 times 4 divided by 2, 10 possible connections amongst those 5 people, but none of them are present in the cartoon on the far left, so 0% density. In the next cartoon over, 4 of those connections are present, so 40% density. And in the final cartoon, all 10 of those connections are present, so 100% density. And then what Utsi did is he plotted on the x-axis the density of the Broadway musical production company, and on the y-axis the success rate of the Broadway musical production company. And he measured success either in terms of how much money these Broadway musicals made, and as you guys may all know, these are very expensive, cost hundreds of millions of dollars. They're like big businesses and could raise lots of money, or they could be a flop. So he plotted the success rate on the y-axis in terms of the amount of money that the shows made, or the fraction of positive reviews. And what he found was that if the density was very low, was 0%, if nobody knew each other from before, the show was a flop. And at the other extreme, he found that if everybody knew each other from before, the show was a flop. Optimal success in these teams was reached in middling level density, whether measured in terms of how financially successful or how critically acclaimed were they Broadway musicals. So people can be organized and connected in particular ways, and this affects what they are able to do. The organization has value. Okay, so these sorts of observations have suggested to us 3 broad ways to intervene in networks so as to enhance public health and public policy and to use social networks for good. I'm probably only going to be able to talk about the first 2 in the time I have allotted, but if I have some time, I'll get to the third one as well. The first idea is connection. Here is that you manipulate the structure, you engineer the connections between people, the wiring diagram, who's connected to who. For example, you can bring a group of people who want to lose weight, who are not connected to each other. You bring them in and you introduce them to each other in like a Weight Watchers group, and now they're, let's say, better able to lose weight. That structure, that fact that you've added the connections, makes them capable of doing something. A second idea is contagion. You say, well, it's difficult in practice to force people to befriend each other or break ties between people. Let's just accept the network as it is, and let's instead try to manipulate the flows. Let's ask, to whom should we introduce a new idea in a group of people, such as to maximize the flow of this thing within the network? And the last idea is a position intervention. This is the idea of, like, given a network structure, who should we put where in the structure to optimize the functioning of this network? And there's expanding science in all three of these in both online and offline settings. And I want to give you just a quick feel for some experiments in the time we have. Over the past few years in our lab, we've developed some software that we call Breadboard that we've uploaded and made publicly available. It's available at breadboard.yale.edu. This software is seamlessly integrated with Amazon Mechanical Turk and with other sources of human subjects. Over the years, tens of thousands of people have come into our online laboratory to play some of these or participate in some of these experiments. And what we can do with this software is we can create temporary artificial societies of real people. And then we can sort of engineer who's connected to whom, or how much information people have, or what are the rules for communication, and then test ideas about social organization in an experimental way. Here's some work we did, earlier work, about 11 years now, that involved the manipulation of connection to affect how cooperative people in a group might be. So on the bottom, we created a little network that's shown in that pattern, and we dropped real people into the positions of that network. And we introduced them to their new neighbors, and we said, here's some money. You can contribute the money to your neighbors, and then we'll double it. If you do that, your group and your neighbors will benefit, but you have to pay a little bit of a price. But hopefully your neighbors will do the same thing, and then you'll be well off. And they played this game across multiple rounds. On the bottom shows what happens when the rules of engagement of the network structure are that the network is fixed. People are stuck with the neighbors that they're introduced to at the beginning. The blue dots are the nice cooperative people, and the red dots are the mean defectors who are selfish and don't cooperate. And in the beginning, about 2/3 of the people are blue. They start off being nice to their neighbors, but then they see that their neighbors aren't reciprocating and are taking advantage of them, and they don't have any option but to either be suckers and keep giving to their neighbors or change to be defectors themselves. And that's in fact what happens. And across time, by the 10th round, you can see that defection has taken over the system. Everyone is a red dot, except a few blue dots on the far right, sort of keeping civilization alive, being nice to each other. In a different branch of the experiment, however, we allowed people, in addition to choosing whether to cooperate and defect at each round, we allowed them at every time step to make a little change in their network, to maybe cut a tie to a defector, or preferentially form a tie to a cooperator. So this connection intervention totally changed the dynamics of the game. In this version of the game, as you can see, across time, cooperation persisted and grew in this situation. But the point of this experiment is that I can take a group of people and I connect them one way, and I can make them really sweet to each other. Or I take the same people and connect them another way, and I make them really mean jerks to each other. So it's not the people themselves that's important, it's how they're connected that is crucial in determining whether this property of cooperation can emerge in the group, just like the diamond and carbon example I gave you a short while ago. Here's another result on the importance of network structure. Here we became interested in the sharing economy and in ways of optimizing sharing. And we built a game that captures some pertinent features of the challenges of sharing. And the game we built said, imagine you living in a neighborhood, and every house has a wireless router. And during the day you use the router, or while you're at home, let's say you use the router, but then you leave home and you can't benefit from that wireless bandwidth anymore. And you should be quite happy to let your neighbor use it. And conversely, maybe when you come home, your neighbor's left, and they might reciprocate and let you use the bandwidth, which is otherwise useless to them. And in this game, people repeatedly choose whether to share an unused resource, the Wi-Fi bandwidth with their neighbors. And then we can measure quite a bit about this behavior, including whether people reciprocate with each other or how satisfied are people to be in this community. And here's a sneaky experiment that we did. We dropped people into two different network structures, shown here on this image. Now, what's interesting about this image is that in both of these networks, there are exactly the same number of people, 15 people, and exactly the same number of connections, 18 connections. And in fact, in these two networks, there's something else that's really creepy, which is the number of people with each number of connections is the same. That's shown on the lower left there in that little table. So for example, there are 6 people with 1 connection in both graphs. And there are 3 people with 2 connections in both graphs. And there are 3 people with 3 connections in both graphs. And there are 3 people with 5 connections in both graphs. If I dropped you into these two networks, you could not tell the difference of what world you were in. You would have 15 people in both worlds. There would be 18 connections in both worlds. The number of people with a different number of connections would be the same in both worlds. And yet the networks would have been organized according to this property, which I won't go into, which is whether the ties were assortative or disassortative. In assortative networks, popular people are connected to popular people, and unpopular people are connected to unpopular people. And in disassortative networks, popular people are connected to unpopular people. Like the airline network, for example, there are hubs, Chicago and Denver and New York, connected to unpopular airports. It's not like all the hubs are connected and all the unpopular small airports are connected. That's a disassortative network. Instead, we humans make assortative networks, it turns out. The point is, however, that the satisfaction of the humans and the amount of sharing was higher in assortative networks than disassortative networks. By engineering the structure of the connections, we could change the experience of the people within it. So that's a second connection intervention that I just introduced you to. Now we can also do something completely different, which is to perform experiments that manipulate contagion. Let me give you a paradigm of such an experiment. Imagine that you have 2 villages, or it could be 2 classrooms, or it could be 2 workplaces, or 2 cities, and you're trying to foster something. The adoption of recycling practices, the adoption of a new product. In a firm, you want to reduce absenteeism, or you want to increase hard hat wearing, or among your customers, you want to have them talk about your products, for example. But in our case, it was 2 villages in a developing world setting, and we wanted to get them to adopt a public health practice, like breastfeeding or vaccination or latrine usage, for example. And imagine you have just enough money on the right to target 6 people in this village. Now, the ordinary perspective in public health is you target those 6 people, and then you come back a year later and you measure what fraction of those 6 people adopted the practice. And maybe of those 6 yellow dots, 3 of them adopted the practice. And maybe because they were embedded in this, but that's not what I'm interested in. I'm not interested in response to treatment among the treated. I'm interested in response to treatment among the untreated. I want to know what everyone else in the village did when I taught those 6 people to clean their water, for example. So maybe 3 of those 6 adopted the practice, maybe 3 of their friends wound up adopting, for a total of 6 people on the village on the right. And in the control village on the left, maybe 2 people wound up doing this new thing just by secular change. But now you should be thinking, maybe we don't need to pick the people at random. Maybe we can use some kind of mathematically informed way of identifying who is structurally influential in the village and choose them instead. For example, maybe we could choose 6 central people. And once again, maybe 3 of the 6 yellow dots that are now in the middle there on the right, maybe 3 of the 6 adopt, but maybe they persuade 30 of their friends to adopt. So same village, same number of people targeted, same intervention, 10 times the effect, because we've now thoughtfully chosen who we target. So these 3 people might persuade 30 of their friends to adopt. And we could then begin to experiment with all kinds of other algorithms of picking such influential nodes. One of the algorithms that we explore a lot is based on something known as the friendship paradox. Now, the friendship paradox is the idea that on average, your friends have more friends than you do. In fact, your sexual partners have more sexual partners than you do too. And then what's most depressing for me is if you're a scientist, your co-authors have more co-authors than you do. And this is a mathematical fact about networks, but I can cultivate an intuition by having you look at the periphery of this network. And at the very edge of the network, you can see there are individuals who have one connection. For example, if you look at the far right of this graph, you see there's that one person there. They have one connection. That's why they're on the edge of the network. But their connection has two connections. They're further in. So for everyone on the edge of the network, their friends must have more friends than they do. In fact, if you look at the bottom yellow dot there, that person has one connection, but the orange person they're connected to has 8 connections. So on average, your friends have more friends than you do. And this holds not just for the edge of the network, it holds all the way through the middle of the network. And what this means is that if we pick the 6 yellow dots at random and take one step away from them in the network to the orange dots, those orange dots will be more central and have more structural influence than the original yellow dots. And the beauty of this is that we can find the orange dots without mapping the network. We don't have to map it. Just pick a group of people at random in a classroom or in a village or in a firm, identify who they're connected to, and deliver the intervention to those other people instead. So here's a quick snapshot of some of our work exploring this idea. For instance, in rural Honduras. Where we work in rural Honduras is a very poor part of the world. People here live on less than $2 a day. The villages are very isolated, and they're isolated from the world in general and isolated from each other. And this is sort of what it looks like. We've created some other software, which we've also made publicly available, which can be used to map networks. It's tablet-based software or web browser-enabled software as well for use in non-rural settings. We call it Trellis, and it's available at trellis.yale.edu. And in one of our first projects, published in The Lancet in 2015, we mapped the networks of all the adults in a sample of 32 villages. And then we randomly assigned the 32 villages, which was over 5,000 people, to one of 3 different targeting algorithms, with 5% of the people chosen in each village. In some villages, the 5% were chosen at random. In other villages, the 5% were chosen according to this who had the highest degree, who had the most connections. And in the remaining third of the villages, the 5% were chosen according to this friendship nomination technique. And our question was, how do we move a whole village and not just individuals to change their behavior? Given a budget constraint, who do we target? And in fact, who creates the most externalities? Who creates the most spillovers for behavior change? And how can we exploit this? This slide illustrates one of the networks of one of the villages. And then we've just, for illustrative purposes, picked 5% of people at random. Those are the orange dots. Or 5% of the people who have the most connections. Those are the yellow dots. And you can see that visually, they're very different people occupying very different places in the network. And this slide shows some of our results. On the x-axis is the days since initial targeting, and on the y-axis is the proportion of people adopting a new product. This is a multivitamin product across time. And you can see that the friendship nomination technique, which is shown in yellow, dominates the other strategies and leads to the most rapid and most complete adoption. Now, we followed this up with a very large randomized controlled trial that we just completed a couple of years ago. We're still publishing this, involving 176 villages and 30,000 people in another part of Honduras, supported by the Gates Foundation and the Ministry of Health in Honduras and the Inter-American Development Bank and some other funders. And here what we did is we mapped the social networks of all 30,000 of these people in these 176 villages. It's one of the largest mappings of face-to-face networks ever conducted. And we did an experiment that had what is called an 8x2 factorial design. We experimentally manipulated what fraction of people in each village were chosen to get this 2-year maternal and child health intervention. Were 0% of the people chosen, 5, 10, 20, 30, 50, 75, or 100% of the people chosen in the village to get this maternal and child health intervention? And how were they chosen? Were they chosen at random or using the friendship nomination technique? And we had 11 villages in each of those 16 cells for a total of 176 villages. And on the panel on the right illustrates the kind of results we theorized we would get, and to steal the punchline, we did get. So on the x-axis is the percent of people targeted. That's the fraction of the people to whom you market the product, 0 to 100%. And on the x-axis is the percent of the people who adopt the product. Now that is capped at 50% for illustrative purposes here. For example, if you were marketing tampons, even if you marketed it to 100% of the people, only 50% could even in theory adopt it. So sometimes there are limits. You might advertise a product to everyone, but you're not going to get everyone to adopt it. Or for example, if this were an infection, even if everyone were infected, not everyone would get symptoms. Some people would be immune. That's why the y-axis doesn't go up to 100%, but it goes up, let's say, to 50%. Now, if the effect were linear, and the more people you marketed the product to, the higher the fraction that adopted, you would have that purple line. You market it to 100%, 50% adopt. You market it to 60%, 30% adopt. You market it to 20%, 10% adopt. But you should all have the intuition that that's not what happens. It's not a linear response. It's this sigmoidal shape shown in the dotted red line, because there is a social effect. At low marketing or targeting fractions, let's say 20 to 30%, even though you reach those 20% of the people, they don't adopt. Why aren't they adopting? Well, because their friends aren't adopting. The lack of adoption by their friends, this social effect, suppresses adoption until you reach the critical threshold of around 45% in this example. And then you have skyrocketing adoption such that above that threshold, the social effect that previously suppressed adoption now facilitates adoption. Those extra customers are easier to persuade to adopt it once all their friends have adopted. That's why there's this sigmoidal shape. Our question was, if we shrewdly pick the percentage using the nomination targeting technique, can we shift the curve to the left by enhancing the social effect? Such that, for instance, when we target 20% of the people, if we pick them in the right way, it's as good as targeting 100%. And the answer is yes. Our experiment showed that this was possible, to thoughtfully and shrewdly pick individuals using network targeting algorithms so that you can foster a cascade in the whole population. And this technique is scalable. The friendship nomination technique is scalable because you don't have to map the network to do it. Find a group of people, ask them who their friends are, and deliver the intervention to their friends. Now, when we did these two papers and we published them, we encountered, however, a practical problem, which is that if you go into a firm or into a classroom or into a village and you ask people who their friends are, and then you say, thank you very much, I'm going to go give something to your friends, those people might not like it. So we most recently tested another targeting algorithm, which is you go into a population, pick people at random, and ask them who their friends are, and then deliver the intervention both to the random people and to their friends, couplets of people and their friends. We call this the pair targeting algorithm, and we theorized that it would shift the curve even more to the left, or even if it didn't shift the curve to the left, would be much more palatable, much more acceptable to people. And that's exactly what we found in a paper that was just published last month or 2 months ago, which in a project we did in India, in Mumbai, working with Tata Chemicals, was our business partner there. They wanted to see, could they foster the adoption of iron fortified salt? They wanted to sell more of this product, which was good for mothers and children, because neonatal anemia and maternal anemia are serious problems. And we wanted to reduce neonatal anemia and maternal anemia, so we were very happy to partner with them. And working in a poor region of Mumbai, in 50 residential units, we mapped the networks, and then we randomly assigned 20% of the people in each of the populations were chosen either at random, using the friendship nomination technique, or the pair targeting technique. And there are 3 illustrative networks shown here from 3 of the 50 groups. And the numbers on the bottom show the size of the group, roughly similar here, 61, 66, 59, and the fraction of people chosen as targets, Again, roughly similar, about 20% of the people, 12, 13, or 8. And what fraction of the whole population, not just the people we intervened on, adopted it? And the answer was 7 people in the random targeting, 12 people in the friendship targeting, and 21 people in the pair targeting. 21 out of the 59 people wound up adopting the practice when we used pair targeting. Now, because of time, I'm going to skip talking to you about position interventions, but I'm going to give you a sort of anecdote about position interventions, and this is to illustrate the point. This paper was just published in the journal Nature in 2017, but the anecdote, so listen to me, don't look at the image. The anecdote is, imagine you're a teacher and you have a classroom and the chairs are nailed to the ground. You have 20 chairs in front of you and nobody's sitting in the chairs yet. But the position of the chairs defines the network of interactions among the students. You know, who's sitting to the left and right and in front of, behind everyone else. So the network structure is given. And now on the outside of the classroom, you have 20 students of differing abilities. The question is, where should you seat the students in the classroom? Into what position should you put each student so as to maximize learning in the classroom? Right? Do you put all the smart students in the front or in the back? Do you mix them up, for example, on the left or on the right? There are different ways you could position the students. The same human capital, the same students, situated in different positions within the network could give rise to more or less learning. Something similar happened in a project we did with engineers in a firm. Given a talent pool of certain engineers, where should the engineers be seated in the engineering division to yield the most patents and the most valuable patents, for example? Anyway, this slide illustrates some position interventions that we've been engaged in where we experimentally manipulate where you put forms of artificial intelligence in online groups. Can we invent bots or other forms of artificial intelligence that affect the behavior of the human beings? And if you think about it, there are many examples of this right now, not just online bots that might suppress racism online or might suppress misinformation online, but even in real systems of people. For example, at the grocery store, where there is an automated checkout and real human checkouts, where should you put those automated checkout devices so as to enhance the experience of both the humans that are clerks and the customers? Or with autonomous vehicles, how should you program autonomous vehicles to drive on a highway, not just to maximize the safety of the people in the autonomous vehicle, but so as to change the behavior of the other human drivers on the highway? And on and on. There are a number of examples of this. If you're interested in this idea, I published an article in The Atlantic a few years ago, which you can easily find if you Google Christakis and AI and The Atlantic. Okay, I want to close with one final idea, which has to do with what it means when we intervene in social networks. Because I think such interventions provide us with a way to manipulate what is known as social capital. Now, to understand one sense of this, consider this idea. What's the point of a connected life? How does it help us as individuals and as a species? And it turns out that networks are a resource we can all use. Networks are a kind of social capital. Now, most people, when they think about capital, think about money. But really, capital is any stock of resources that can be put to productive use. So capital is a reservoir of wealth. It's a stock of resources that you can do something with. And two further key ideas about capital are that in order to create capital, you have to invest skill and effort. You have to know something and do something in order to create capital. And second, and more subtle, and in an idea that's been keeping me awake for 20 years, is that in order to create capital, what you really have to do is make changes in a substance that make it yield a higher rate of return than it otherwise would. That at its core, the capital creation process is about a transformation of the natural world, where you invest skill and effort to convert one thing into another thing, and that's what endows it with its productive power and what makes it a reservoir of wealth. For example, a farm is a stock of capital. You can take a forest and invest skill and effort and clear the land and make a farm. And a farm is more valuable typically than a forest because you can do things with a farm you couldn't do with a forest, namely grow fruits and vegetables and flowers and grains, for example. So you invest skill and effort, you transform one thing into another thing, and that's what makes it a source of capital and a reservoir of wealth. Or consider this idea. You could take this tree and invest skill and effort and transform it into lumber. And the lumber is more valuable than the tree because you can do things with the lumber you couldn't do with a tree. Namely, invest still more skill and effort and convert it into a violin. And the violin is more valuable than the lumber because you can do things with a violin you couldn't do with a lumber. Namely, make music. So at each step of the way, you invest skill and effort, you transform one thing into another thing, and that's what makes it a reservoir of wealth and a kind of capital. Well, a key innovation in thinking took place in the 1960s amongst social scientists and amongst businessmen and business people and women to begin to think about people and their skills and talents as a form of human capital. And the chief example of this is education. So you can take, for example, this dissolute former graduate student of mine on the far left, who's, let's say, a drunkard, and you can clean him up. You can send him to AA. And now he's in the middle. He's more productive. He's capable of doing things he wasn't previously able to do. And you can invest still more skill and effort and give him an education. You can work on the neurons of his mind. In principle, that's what I'm doing right now, too. I'm investing skill and effort, and I am changing your minds and making you capable of doing things you were not previously able to do. Of course, you're also investing skill and effort. That's another topic. Well, just like physical capital is created by a change in the material world, and human capital by a change in persons, social capital in organizations, in companies, in communities, in our whole society is a change in the relations among persons, a change that renders the group more productive and capable of doing things it was not previously able to do. And that is the deepest account I can give you of what social networks mean for our lives and why it is and how it is that we can use them to make the world better. Thank you.
Thank you, Nicholas. Love all the bright colors in your diagrams. That was amazing. Much appreciated.
You're welcome. I can't remember whether you want me to do questions or should I say goodbye?
We're not going to do questions since we're in a broadcast, but thank you so much. Thanks for joining us.
Thank you all for having me.
Awesome. I'll be going to buy your book soon. You've hooked me.
Thank you.
Thank you again. Everyone in the broadcast and the webinar, we're going to take just a 5-minute break. The winners have been selected. So we're going to regroup on our end and we'll be announcing them in just 5 minutes. So please stick around. See you soon.
Okay, welcome everyone. The judges have deliberated. We've heard amazing speakers. This has been 2 days of fantastic ideas. It's just been spectacular for our team, and I hope for the Mars team as well. I am stalling because I want to increase excitement. So I'm going to now use this opportunity to pitch our book, and then we will announce the winners. If you haven't already checked out Grow the Future, this is our new book. It took us 2 years plus to make this. It has projects from the biodesign community. And I think it has some of the cutting edge ideas around what is possible using biodesign. So please check it out. It's on the website. If you haven't already bought a copy, please buy a copy now. First edition, there's only one. All right, now I am going to call up some of our favorite judges to announce the teams, announce the winners of the finalists. So I'm going to ask Paula de Almeida and Tasha Tucker to turn on your cameras. And they are going to announce the winners of our student runners-up. Okay, the floor is yours.
Thanks, Dan, and thanks everyone for the amazing projects that were put forward. The amount of thinking behind these challenges and the novelty of how you've approached it has been so inspiring. I could speak. I know some of my Mars colleagues will speak as well. But from an innovation standpoint, I was so excited and very giddy about it. So thanks for all your efforts. But we're here to talk about the runner-up for the students. And we were really inspired. We had a really hard decision to make between all these 4 efforts. But we have agreed that for the runner-up, we're going to reward this project that was incredibly avant-garde, if I may say. It was on the frontier to really testing how do we think about ingredients and experiences very differently. How do we resolve for a real human challenge in a very novel way by leveraging materials, not necessarily feeding people directly, but giving them the experience of what they would have within their consumptions. And so very novel way of tackling some real human problems, in this case, sugar consumption, if I may say. And I'm starting to give a little bit more details here of who the winner is. And so I'm going to invite Tasha to actually award the team and give the prize. Tasha, please.
Yeah, Paulo, I'm so excited about this team in particular. Being a Biodesign Challenge alum from what seems like centuries ago, I know the stress and the hard work and the thinking and effort that goes into these projects. Just having 1 month to crunch these out, I was so impressed by all of them. So to get on to it, the runner-up from the student presentations was Group 4.66920016, or as we call them, 4.66. Well done, guys.
Woo, congrats.
Well done.
Well done.
Congratulations, team. Thank you both for doing this. All right, next up, we have the non-student runners-up. I'm going to ask Beth Fontana and Harpreet Sareen to come on screen to announce these winners. Okay, the floor is yours, guys.
Hi again, everyone. It was such a treat to see all of the teams and the works today. Congratulations to all of the teams. I really hope you will continue bringing these projects to the world in many shapes and forms. Beth Fontana and we are here to announce the runners-up of the Biodesign Sprint. For this runners-up team, the judges really appreciated the depth in systems modeling and interactions this team built, and the fact that you were able to get out there to talk to many stakeholders. I will pass on to Beth.
Great. I am really honored to make this announcement, especially having grown up in a community like what this team focused on. So I'm very pleased to announce that the University of Minnesota Biodesign Collaborative, with their Fair Farm concept, is the runner-up. So congratulations, team. Really well done.
Thank you, team. Congratulations. Thank you, judges. Okay, next up, we have the winner for the are you coming on for student? Okay, then we're going to do student finalists, the student winners, rather. And I guess I will provide the context here. The team proposed creating a new type of dessert that you would eat, and it would clear the microplastics from your gut. The judges congratulated the teams on thinking really deeply and differently about what appears to be a new problem that researchers only identified now. They did, however, warn that this is still a speculative project, and there's a long way to go before such a thing might be possible. That said, they were very, very pleased to declare Coast to Coast as the winner of our student teams. Congratulations, Coast to Coast.
For their project Candy Caps. I'm looking forward to having some in a few years.
Well done, team.
Congratulations, team. All right, moving right along.
Yeah, we're sorry, Alex, I stole your thunder there. I'm going to call up Dandina Bradley and Arthi Gopal to announce the winner of the non-student teams. Go ahead, please.
Absolutely. First off, I want to say thank you to all the teams who participated. The caliber of projects, the ideas and the depth and rigor put behind it just exceeded all of our expectations. And I think you've heard some of that from our other judges. So heartfelt thank you for all the effort you've put in, and congratulations across the board for doing an amazing job. But that said, we did have to make a choice. And I think the project we've selected was really highlighted for its originality, speaking to, really thinking through indigenous food systems and how to connect the community to solve some of those big challenges that we're facing and that they want to impact. Additionally, they had a passion to drive forward. So really thinking through that system of what will it take to make this successful at the community level, at a commercial level, even at a funding and support level. So with that said, Dandina, drum roll.
Yeah, the winner of our non-student project is Chi-Town Bio for their project Sprouted. And what better way, right, to think about rewarding care, being kind, right, and connecting your friends all together to really go after this. So just thanks everyone for all of the great, amazing ideas. It's been a wonderful, wonderful day. I'm excited.
Thank you, Dantina. Thank you, Arthi. Thank you, Chi-Town. Congratulations. I'm going to ask everyone to turn on their cameras. Why don't you join me for the sort of the closing moment of this event? We'll give you all a second to pop on. If more folks out there want to turn on their cameras, you're welcome to. There we are. I have a lot of folks to thank for making this last month happen. Firstly, I have to thank the Mars team for showing up for our community and for joining us in this exploration. Arthi and the BDC team have been meeting weekly for, oh my gosh, as long as my memory can tell, to make this happen. Dantina, thank you for your leadership in bringing everyone together. Judges, you were incredible and continue to be incredible. And I think we were very lucky, both as biodesign explorers, to have your wisdom and your experience with us. I should also add the BDC judges that we brought on. Oh my gosh, you guys are amazing. And it's just been an unbelievable pleasure to hear your thoughts. I want to thank Jeff and the team at Argus for working behind the scenes to make this go as smoothly as it possibly can. Thank you, Jeff. It's now been, I think, 3 years that we've been working together, and every time it is a pleasure to work with you all. And of course, I have to thank all the participants that came out of all over the world to produce ideas that were surprising, were exciting, that it was just a pleasure for our team to help guide and see how they grew. This is, of course, the beginning of your journey, right? You've only had a month. Now imagine what this would be like in a year's time, or 2 years' time, or a decade from now. I really believe that whatever you do is going to be incredibly inspiring to the biodesign community. So I like to joke that we're incredibly sticky as an organization. I think that's true. Now that you're part of us, we're not going to let you go. Take that how you will. But I just want to thank everyone for doing this with us. It was inspiring, and here's to many more of these programs and competitions and ideas to come. Thank you all.